Okay, good morning, good afternoon, good evening. Depends where you are, if you are in Latin America or if you are in Africa or anywhere else. So, thank you very much to join us for this event today. So, uh, it's probably first in CASS site to have a joint workshop between Africa and Latin America. Uh, so, welcome to all of you. So, today we have a nice program. So, first, I give the floor to Fidel to do some presentation about Kenya. Then I'll do some short presentation about Rio Grande do Sul and Porto Alegre. Then we have a session on education, on electronics and microelectronics with Professors Thiago Bale and Shardrock Mambo. Then a talk by Fernanda Castensmith. Uh, then we have a short 10 minutes break. And then we start with a session about electronic and microelectronic industry in Brazil and Kenya that will be presented by Latif Querono and Sergio Bumpi. And then we have a presentation about the activities of the chapter Rio Grande do Sul that got the old chapter of the year that will be done by Professor José Zambuja. And there will be also some planning of activities in Kenya as well in Rio Grande do Sul. Then we have some final remarks. And then this will be followed by the CASS talk of this Friday that will be given by Sandro Ferreira from Unicinos Brazil. So now the floor is with you, Fidel.
Okay, thank you very much. Um, Good morning and good afternoon, Brazil and Kenya and all over the world. My name is Fidel Makachia. I am the current BOG YP representative in CASS, IEEE Circuit Assistance Society. I come from Nairobi, Kenya. So I just want to talk about Kenya in a few minutes. So Kenya is one of the countries in Africa, over 54 countries in Africa. Kenya is one of them. Kenya is also one of the countries in East African Community. Part of other countries include Uganda, Tanzania, Rwanda, Burundi, and other countries. So Kenya is one of the has 55 million people in population total, over 42 tribes. So it's a whole 42 tribes, a lot of tribes. Is among the most industrialized and wealthiest nation in East and Central Africa. So Kenyans speak both English and Swahili, local language, as official and national language. So you can either use Swahili or English as an official or even national language. We have one thing that Kenya stands out is wildlife and physical features. You can do very good, cool safaris, and you can see a lot of wild animals as seen from my slide in Kenya. So guys like visiting Kenya to see these wild animals and do safaris and a lot of physical features, including Mount Kenya, the tallest mountain in Kenya, and other mountains which exist, including ranges like the Aberdares Range. There's so much. Kenya has 47 counties. We used to have provinces, but we later changed to counties. So each county has its own local government governing it, but one nation. Nairobi is the capital city of Kenya. We have 4 cities in Kenya. That include Mombasa, which is at the coast region, next to Indian Ocean. That includes Nairobi, which is the capital. That includes also Kisumu. Kisumu is a city at the lakeside, Lake Victoria, that feeds one of the sources of River Nile. River Nile is the longest river in the world that flows all the way through Egypt, Mediterranean Sea. So tea is one of the leading cash crops in Kenya. There are other cash crops though, but tea is among the leading. Coffee is also exported, and we also have minerals that we export as a country. So let me focus on the city, which is Nairobi. It is the biggest city in East and Central Africa. is the capital of Kenya, is a leading business and tourist attraction and destination in the country and actually in Africa and in the world at large. So it's a very big city, and it's among the few cities in the world with a national park inside. So inside Nairobi, it's a green city in that it's integrated with the wildlife. So there's a place. It's not a zoo whereby you bring animals to cage them. No, it's like a whole animals in their natural habitat. Then the city integrates with them. So it's a very nice scenery. I'll show it in the next slide. You will see. So Nairobi also houses the headquarters of UNEP, that is United Nations Environmental Program. So the HQ is in Nairobi, mostly because of the green nature. Actually, the name Nairobi means a place of cool waters. So it tends to be cooler and cold compared to other parts of the country. Five interesting things about Nairobi: world-class infrastructure. I'll show the photos, the next slide. World-class facilities and amenities. Nairobi is a tech capital of Africa. So most companies and startups that are around Africa and even the world actually have their either offices, branches, or even headquarters in um, in Nairobi. I'm sure you've even heard of the famous M-Pesa innovation, whereby you can send money via text message, and of course other innovations and other startups. We have even companies, big companies in the world, tech companies, forming their African HQ in Nairobi, because it's a very industrialized city in terms of technology, mostly fintech, financial technologies. Nairobi has more than 5 universities inside the city itself. Of course, among them is my alma mater, Kenyatta University, but we have others, University of Nairobi, Strathmore, and many, many more. Um, yes, so these are part of the things I've talked about. Here you can see the Hilton Hotel building in Nairobi. You can see the KICC, that is Kenyatta International Conference Center. You can see the Nairobi Safari Walk. So you meet these animals at their natural state. So they are doing what they usually do before civilization came. So, and it's inside the city, so it is integrated with the city, is not far. Also, you can see Kenyatta University. So, I'm so happy to talk about my country as a Kenyan, and I want to invite everybody, and especially guys from Rio de Sol, we should do a physical workshop and activity here in Kenya. You're going to enjoy it from the good people, nice people of Nairobi, very welcoming people, all the way to the good infrastructure, all the way to even the wildlife. Yes, thank you so much. Back to you, Prof.
Thank you very much, Fidel. It would be a great to have the opportunity maybe next year to visit
Yes,
Nairobi. And so
yes,
now we'll do a short presentation about where we are. So we are in the south of Brazil. So here you have the map of South America. So in red here is our state. So our state is doing border with Uruguay and Argentina. Have south of our state is the land of the Brazilian cowboys. So it's the land of the barbecue. So when you see a restaurant around the world saying Brazilian barbecue, the origin is from here. So Porto Alegre is in the border of a larger lake. So this lake that is called Duck Lake has about 200 kilometers long, and the connection to the ocean is in the south border. Uh, on the top, in the northwest of the state, we have the region of the Jesuit missions. So it's nice to go there. Then we have the most traditional wine region in Brazil. Now there is a new one closer to the border with Uruguay that is doing nice wines also. And we have some nice tourist cities in the mountains here, Gramado and Canela. That, by the way, this weekend is starting the movies festival. That is the main movies festival in South America. And here there is some very nice green canyons, so we are going to see some photos. And Porto Alegre here is 1.5 million inhabitants, but the metropolis of Porto Alegre is about 3 million. No? Then here is a view of Porto Alegre from the lake. So here is the old port. Now there is a program to renew it and to have more restaurants. There is already a set of restaurants in the border that is nice to go to see the sunset. So here is some photos of the board of the lake. So there is a big renewal of the border. And this tower here was an old electric power generation. Now is a cultural center. And on the right here, you have a very nice museum in the top that was designed by the famous Portuguese architect Álvaro Siza and is dedicated to a local famous painter. Here is some other views of the city. So this location in the border of is also used for larger shows. Then here in the top is a short view of one of the historic buildings in downtown. So I don't put many slides from downtown, but so we have two big soccer teams in Porto Alegre. Both were already world champions of the championship of clubs. One is the name is Internacional, and this is the stadium of Internacional. So when the World Cup was in Brazil, the World Cup was played here. No? Then we have also another stadium that is a stadium of the team that I support, that is the blue one. So Grêmio was the first team in the city that was world champion in many years ago. So it's nice to, if you have the opportunity to come to Porto Alegre to see a game here in these stadiums. Here is some photos of the region of the Jesuit missions in the northwest of the state. Here is some views of the surroundings of the cities of Gramado and Canela. That is a very nice location also to see. Here is a view of the Green Canyons in the northwest of the state. So these canyons are about 600 meters deep. Here is a view of one of the beaches that is in the border with the state of Santa Catarina. So it's another interesting location to go. And we are the main Brazilian wine region, so probably 90% of the wines produced in Brazil are here. And the sparkling wine here already got more than 100 awards in France. So, and here on the left, you have a view of our way of preparing barbecue. Here is the Center for Microelectronics that started in Porto Alegre. Now is waiting for some improvements, expecting that we are going to have a new government in Brazil. So on the right is the fab, and on the left is the design center. And here is some other view of the. So let's see if I manage to show you a short video. And I have to change here the window. Sorry for this. Okay. So some parks. This is the administrative center of the state. Okay, so this was a short presentation of the city. Sorry that when I put in full screen, it was not showing. It appears, no, but so now we can go to the next session that will be about education. So the first presentation will be done by Professor Thiago Balin. Thiago Balin is the head of the graduate program on microelectronics here in Porto Alegre. And the graduate program on microelectronics is the only program in Brazil focused only on microelectronics now. So Thiago, the floor is with you.
Okay. Thank you, Ricardo, for this invitation. It's a pleasure to welcome our colleagues from Kenya here in this joint workshop. I will talk about a little bit about education in microelectronics in south of Brazil. The agenda of my presentation is first I will present myself. Then I will talk about the importance of microelectronics sector and also the importance of human resources and universities for this sector. And I will talk a little bit about PG Micro because I suppose that almost all the research activities that are performed in South Brazil have some similarities from the researchers that we perform in PG Micro. And finally, I will present the interactions that we have with the industry. My name is Thiago Balin. I am an electrical engineer. I got my degree in 2003 from Federal University of Rio Grande do Sul, and my PhD in 2010 from the same university. My first lecturer position was in a professional education center in Brazil, that's Senai. It's a big national education center for industry and technical professions and technical education. It was in 2005. The same year, I started as a lecturer in private university, in which I was the coordinator of the telecommunication and computer engineering courses. I had also a short actuation at SEITEC in 2010. And since 2011, I am a professor of Federal University of Rio Grande do Sul, in which today I hold the position of head of the graduate program in microelectronics. So let's talk about a bit about the importance of the industry. Here we have the one map showing the economic complexity index of Brazil. In the bottom of the screen in right, you have the position of Brazil in a World Economic Complexity ranking. It means that we are not a very complex economy, and this ranking measures in somehow the let's say how a country have a spread spectrum of economic activities. So we can see that we have not a very complex economic, nor not a very let's say variable economy. So we have to improve the investments in science, technology, and education if you want to increase this position and go to the positions of the developed countries, in which we have, for example, high technical activities in the economy of the country. So the microelectronics is very important, not only to develop the electrical and electronic industries, but these activities are very important to add value for example, tools and equipments that are used in almost all of the industry activities, not only in the consumer electronics, as for example in vehicles and medical instrumentation and so on and so forth. So to accomplish this, we have to support all the activities that are involved with education in technology and microelectronics. How the academia is how is the importance of the academia in this process? So we are responsible to form qualified professionals in the undergraduate course. But if you look to the graduate programs, we are now forming high standard professionals which have higher skills as researchers and teaching, for example. In the graduate programs, we perform research in which we produce the knowledge and we develop the knowledge. And we also do extension projects in which this knowledge is applied to the society. The micro and nanoelectronics in our universities in Brazil, in south of Brazil, are inserted in specific courses, as for example, the PG Micro, that I will talk a little bit more afterwards, and also as formation or formative lines in the undergraduate courses like electrical engineering, computer science, and physics, for instance. Here we have a map with the main universities in Brazil that are doing activities in microelectronics in south of Brazil, sorry. We have some of them in Paraná state, that is the one in the top of this little map. So in Rio Grande do Sul, we have several universities. We have also in Santa Catarina state, that's our neighbors in the south region. We have here in Rio Grande do Sul our university, that's Federal University of Rio Grande do Sul. but we have another 4 important federal universities here and some private universities, as well as a state university and the federal institutes that are also performing research in microelectronics. We have formed in the last year a huge research network that we call it here InnovaShip. That's composed of more than 50 PhDs that are researching in several microelectronic areas. Here we have another map that is from Microelectronic Society from Brazil that shows the institutions that are enrolled in a program that provides license support and finance of to purchase license of EDA tools and also to prototype integrated circuits. We can see here that here in Rio Grande do Sul we have several institutions that are enrolled in this program. So in this map you can actually see also the microelectronic activity spread in Brazil. So we can see that Rio Grande do Sul state, alongside with São Paulo, are the main states in which the microelectronics activities are performed. And here in Rio Grande do Sul, we have a strong focus on design and test and EDA, as I will show you afterwards. So the start of this movement in Brazil, I can say that we have here in Rio Grande do Sul, at Federal University of Rio Grande do Sul, 3 wizards of microelectronics that are the professors Altamiro Suzin, Ricardo Reis, and Sergio Bampi that more or less 40 years ago started a microelectronics group in Federal University of Rio Grande do Sul. We have now 3 as a consequence of this movement. We have now 3 graduate programs that in which we have microelectronics activities that are the PG Micro, the graduate program on microelectronics, and also the graduate programs on electrical engineering and the graduate program on computer science. So in PG Micro, that's the program in which I am actively enrolled. PG Micro started in 2003 with the doctorate in microelectronics. It's the first and only multidisciplinary microelectronics program in Brazil. So the master course started in 2007, and it's composed of 23 professors from 4 units of Federal University of Rio Grande do Sul, from the Physics Institute, the School of Engineering, specifically the Electrical Engineering, the Institute of Informatics, and Institute of Chemistry. Today we have about 60 enrolled students, and we formed 2005 graduates, being most of them the master's degree, but we have also an expressive number of graduates in PhDs degree. The main research areas that we develop here in PG Micro are the physical and chemical process of materials and device, physical and chemical characterization of materials, the characterization and modeling of electronic devices, integrated circuits and systems design, test of circuits and electronic system, and electronic design automation. We can say that with the exception of the first 2 research lines, the other lines are also the lines that are developed in almost all the institutions of Rio Grande do Sul state. The lines that are focused on the devices and materials are more or less concentrated here in the Federal University of Rio Grande do Sul. Here we have some pictures and the research lines of each line. So we have, for example, in the electronic device, we have research lines in characterization, photosensitive device, electronic device modeling, and so on. In the test of electronic systems, we research in fault injection, integrated circuit test methodologies, design for testability, and qualification of integrated circuits under radiation. In the physical chemical characterization of materials concentration area, we study nanostructured optical films, dielectric materials, electronic, structural, magnetic, and transport and other properties of materials. The huge line that we have, the biggest line that we have in the program is the integrated circuits and systems design, in which we develop studies from video applications, analog applications, RF, low power, digital systems, design of radiation tolerant devices, systems on chip and FPGAs, for example. We have here some pictures of some integrated, we have prototyped in the last 5 years using MPW multi-project wafer initiatives from other countries, and also here in the past we had in SATEC another initiative, another similar initiative. So we have here 22 prototyped circuits in which our students can direct apply the object of research of their masters and PhDs works. We have the other lines that are the physical and chemical process of materials and devices, as I said before, in which we studied the CMOS device and technology, materials for information technology, nanostructures, and so on. Another important line is the electronic design automation with physical synthesis, logical synthesis, high-level synthesis, and verification. In the past, we also participated in a professional training program that was called the IC Brazil, in which 900 professionals in digital, analog, mixed signal, and RF were formed in 11 years of existence. This program was discontinued in 2011. And we had here in our university a training center that was strongly supported by our professors and researchers. So we interact with the industry forming qualified professionals, and we can see here 2 examples in which professionals formed in the IC Brazil program worked in HD Microns and CTEC SA, that are 2 important microelectronic industries here in the metropolitan region of Porto Alegre. We have examples of startups that are supported by our graduate program too, as for example, the in-place design automation, that is a startup that we have here in Federal University of Rio Grande do Sul. We have some examples of technology development projects, as for example, a power meter that was developed by Professor Sergio Bampi for the Embrasul. That's an industry that we have here. The company Nangate, that was also acquired by Silvaco, that had also participation of our professors. And we have also the possibility of performing a new kind of masters and PhD in Brazil that's called academic masters and doctorate in innovation, that have the active participation of industry. The important microelectronic for the ecosystem, we can see here in the example of the South Brazil, we have university in 3 states with a significant tradition in microelectronics. We had in the past the induction of the creation of PG Micro by CAPS, that's a Brazilian agency for fomentation of graduate courses. The creation of SATEC and also the IC Brazil program with a design a training center in Porto Alegre. And we had also some incentives of some fiscal incentive of government that are altogether builds a favorable environment for the installation of companies in the area. And we have here, for example, some enterprises that are here in the metropolitan region of Porto Alegre, such as HT Micron and Silica and Pinge, Silvaco in place, and another companies in other states too, as Chipus, for example. And finally, we have here some slides showing where are our graduates, our alumni working in enterprises in microelectronics. Actually, these slides were prepared by Professor Ricardo Reis. Of course, they are not up to date because this market is very dynamic. So you can see here several names on several important enterprise. Here some others. Probably you have most of them. Here some universities also, because we have also forming researchers and professors that are spreading the microelectronics knowledge in our country and for other countries too. And with this, I finish my presentation, and now I am open to questions. So thank you, Ricardo, again for your invitation, and that's all.
Yeah, thank you, Thiago. So probably we go to the next presentation, and then we do all questions for you and for Dr. Mambo after his presentation. No?
Okay.
So so I put Dr. Mambo in the. So I don't know if you managed to get your slides. No.
Thank you. No, I did not manage, but I'll just talk through. I'll give a highlight on what I'm going to talk about.
Okay.
Yeah. Thank you once again, and good morning, Brazil. Good afternoon, Kenya. I'll start with the introduction. I'll introduce myself. Then I'll talk about engineering programs in Kenya. I'll talk about electrical engineering specifically and the areas of specialization. I'll also give a presentation on how engineering is taught in Kenya, the kind of facilities, labs, and members of staff that we have, the approximate number of students, collaboration with the industry and academia, and the various research and innovations that we have had recently. And finally, I'll end up with the kind of support we give to our students so that they come out as professional engineers. Yeah, my name is Dr. Maina Mambo. I'm the Dean School of Engineering and Technology at Kenyatta University. I hold a PhD degree in electrical engineering from Shwane University of Technology in South Africa. And I did my undergraduate and master's from Odessa Polytechnic University in Odessa, Ukraine. I've been in academia for the last 16 years, but before then, I was in the industry for another 15 years. So in total, I have about 31 years practicing as an engineer, both in academia and in the industry. We have several types of engineering programs that are offered in Kenya. These are electrical engineering, mechanical engineering, civil engineering, agricultural and biosystems engineering. Those are the mainstream engineering programs. But we also have others like biomedical engineering, which is relatively new, aerospace engineering. We have chemical engineering, gas and petroleum. And I'm sure that there might be some others, like and mechatronics, of course, which is also a blend between mechanical engineering and electrical engineering. At Kenyatta University, we offer 5 engineering programs. That is electrical, mechanical, civil, agricultural and biosystems, biomedical engineering, and gas and petroleum. No, those are actually 7, but they're housed in 5 different departments. Then electrical engineering has several areas of specialization. One, electrical engineering itself, where we talk about power distribution, power systems, and power electronics. Then another graduate can also specialize in electronics engineering and telecommunication. We used to offer computer engineering, but that has been taken into the electronic side as a line of specialization, not a full course. In Kenyatta University, we have some facilities where we used to, which we take our students through to. That is labs, say digital labs, power systems lab, power distribution labs, and computer lab. We also have workshops where every engineering student passes through, especially to do their workshop practice. This is especially after their second year of learning. Now, the programs, all engineering programs are offered in a blended mode. These we adapted after the COVID-19 pandemic hit in, but before then, we just used to have the face-to-face. And we divide our program into 3 phases. We have the theory part, the practical, and of course, the industrial attachment. So the theory is where we give our students in a blended mode, sometimes face-to-face. 70% of the time is face-to-face, and about 30% would be online. Then for the practicals, they have to be, online or through. Then we have 2 sets of industrial attachment, one after the 3rd year and the other one after the 4th year, where our students are expected to be in the industry for a period of 8 to 12 weeks each in each session. This is, however, going to change because through our regulator, the Engineers Board of Kenya, we are planning to change that system to ensure that before a student graduates, he has a whole year in the industry to enhance his employability skills. Then we don't have so many students. Currently at Kenyatta, we have about 1,800 who are engaged from, who have been registered from 1st year to 5th year. And throughout the country, I don't have the exact numbers, but we probably graduate less than 12,000 students every year. We have about 18 universities which are offering engineering programs, throughout the country. And among these, most of them do not have more than 1,000, approximately about 400 to 500 students in all the programs. So that is why I'm saying we have roughly about 12,000 graduating every year. Now, there is a very good collaboration between the university and the industry, because this is where first we take our students for industrial attachment. 2, there is a relationship that we develop with the industry where we get industry problems and we come and research for them and get a solution to that. So for us to be able to do that, then we have to closely engage with the industry. We also engage with other universities locally and outside, say like in US, in South Africa, and in Germany. We have a very good collaboration between several universities in those countries, whereby we have some professors from those universities coming in as adjunct professors in our various programs, not only electrical, but even in areas like aerospace, biomedical engineering, and gas and petroleum. And these adjunct professors helps us to increase our capacity, because locally we have shortage of lecturers to an extent where you find that most of the universities are sharing the lecturers that they have. However, that does not mean we compromise on the quality of education that we give to our students. These, we see it out of the innovations that they come up with. And when they go for their postgraduate programs, we are certain they come out in those programs very well. The kind of feedback we also get from the industry when they get engaged is very encouraging. And every other time we have a curriculum review, which is usually done after a 5-year cycle, we invite the industry players to come and help us in the review. And the kind of feedback we get is that we have very good students coming out of our system. Then about research and innovation, the university has given us a very good, conducive environment for research and innovation, both at the graduate level and at the postgraduate level. At undergraduate level, we recently came up with a ventilator, a medical ventilator, which is, as we talk today, is at the clinical trial stage. And I'm happy to say that Fidel is the team leader of that group of students who in 2020, when the COVID-19 pandemic broke out, came together and came up with the idea of making a medical ventilator. I participate in that as a technical team leader, and we have several people from different disciplines, electrical engineering, biomedical engineering, and we have also incorporated medical students because we believe they are the end users of the equipment. We've brought in nursing students and students from the School of Pharmacy. So as a collaborative team, we have about 15 students who are working on that medical ventilator. Among other innovations that we have done, we were part of, and we are still part of, a team that is that developed the first satellite, 1U, and currently we are working on 3U nano satellite, which we hope to prove as a concept, and maybe in future be part of those who will be launching it in space. This is to help mitigate in identifying the times of drought to help the farmers, invasion of locusts and those kind of menaces that are normally prevalent in Africa. There are several other innovations. We have an egg incubator which has been developed by our students. We have a smart detector system, Apollo, which again, Fidel happens to be a lead person in that. And all these goes to prove that our students are all grounded in matters, especially matters of electronics and engineering, to the point that they are coming up with their own innovation. This is also supported by the soft skills that they acquire, because we train them on matters of for the industrial revolution, that is machine learning, artificial intelligence, Internet of Things, programming and coding, and this has helped them easily come up with innovation. The university also supports these innovative systems by incubating the ideas of the students, and those that can be taken to the level of production. We ensure that the students benefit from them by, getting them to apply for the intellectual property rights so that they own the system. And then we look for funding to develop them to the levels of a final product and maybe even startups. Then finally, we also support our students by mentoring them and ensuring that they're joining professional bodies such as IEEE. We have an IEEE KU students branch. We also have Engineers Board of Kenya Students Chapter and the Institution of Engineers of Kenya chapter. So once we mentor them at the student stage, it becomes very easy to transit into graduate engineers and finally into professional engineers. I'm looking forward to a collaborative session with the Synopsys and this group, and especially on the microelectronics areas who would want to get to know more about VLSIs. So we look forward to these and the future session. And for that, somebody initially mentioned, it would be very good to have later in the year or next year a session that could be either be held in Africa or in Brazil, and we look forward to participating in that, both as faculty and as students. That is all I have for now. Thank you very much.
Thank you, Dr. Mambo. So, Tiago, can you also join us now? Okay, let me put in a better. So, Dr. Mambo, can you stay online?
Yes, I will. I'm online.
Yeah, okay. So now it's open for questions. So if you have any questions, please do it as soon as possible in the chat channel of the YouTube. So not seeing any question for the moment, but I have, I think it will be great to exchange some more information between the graduate programs we have in Brazil and in Kenya, no, and so about the use of the tools provided by the major vendor like Cadence and Synopsys and Siemens EDA. So maybe Thiago can tell something about the experience here in Porto Alegre using these tools.
Okay. Actually, we have as part of the infrastructure of PG Micro an infrastructure called CAD Micro. That's like EDA Micro, in which you have several servers, and with the license of the three major vendors that Ricardo cited before of EDA tools, and our students are very use it to apply these tools in their researches. And we can do also remote access. So during the pandemic, our researchers in design of integrated circuits were not stopped. So the students were able to continue to assess from their houses. And I can say that we have a very active use of these tools. And also, as a final product, some of the research are also sent to prototypes as tape outs. So as I showed you before, we have several of our designs of our students that are also prototyped and then measured, and we have a final prototype of their project. So that's more or less the scenario that we have here in PG Micro with these design tools.
I just would like to add that I forgot, we have also the Silvaco tools.
Yeah.
So Silvaco is also a EDA company that have a development center here also in Porto Alegre. So there is a long history about this because a long time ago participate in the demonstration of the tools developed in our university in the Design Automation Conference. Then the Nangate company approached some of the students that were presenting the tools there. And then it started an agreement of and the development of common lab between Nangate and our university. So in our university, they're responsible for this cooperation were Professor André Reis and Renato Ribas. And then Nangate also opened an office here in Porto Alegre. And then later on, Nangate was bought by Silvaco. So this is the main reason that Silvaco is here. And another reason also is that with this history, there is several former students of our university that are working with Silvaco, not only in Porto Alegre, but also in California. No? So there is experience on this. By the way, EDA is one of the fields that nowadays there is a huge lack of people. No, so it's I think a great opportunity to develop research and education on EDA in Latin America and Africa countries. No, because to develop EDA we need only a computer and also some good skills on programming and algorithms. No? So one question for Dr. Mambo, and how is the development also of EDA in Kenya? There is some research groups working in this field also, or?
Yes, we do. Although in terms of equipment, we don't have good equipment on that line. We have programming kits, yes, but we would require better kits to do research and innovations with. But we have a group of students and lecturers who are working on those areas. In the areas of VSLI, very large scale integrated circuits, we are yet to get the right kind of equipment to work on, and that is why we look forward to what Synopsys are offering or are ready to offer, and that we will welcome with both arms. We collaborate with people like Gearbox, who are, I think they are in this call, and they've been helping our students in, printing of circuit boards and even showing them how to go about the design work. So yeah, that is a much we are able to do, but we hope we'll be able to do much better with the collaboration that is starting from this call. Thank you, Ricardo.
Yeah, it's still open for question, but I still see no questions on the chat. So if you have any question, please do it as soon as possible. And so another question, maybe to Dr. Mambo. So do you, in the undergraduate courses, do you have also some training on and integrated circuits design?
Yes, we do. We do. That is part of the curriculum in electrical and electronics engineering, and we have a lab for that.
Okay, good. So in about Kenya, So, how many universities you have with courses related to electrical engineering and computer engineering and computer science?
We have about 18 universities giving or offering various engineering degree courses, among them electrical engineering, like I mentioned earlier. In our university, we also offer computer science and energy technology. Those are non-engineering degrees, but they are technology programs which complement the engineering degrees that we offer.
Okay.
Mm.
So I don't know if Thiago has some other comments.
No, but I see here in the private chat of the StreamYard a question from Latif Cherono. I don't know if it's the right pronunciation.
Cherono, yes.
How important was the education curriculum sector in growing, catalyzing the electronic manufacturing sector in Brazil? Yes, this is a very, very nice question. As I showed you, we have we had in the past the initiative of the government to install the SEITEC plant here in Brazil. And of course, the Rio Grande do Sul state was one of the states, was the chosen state, because we have here a long tradition in microelectronics. And also we had the support from professors of our university, as Professor Sergio Bump, that was very important in this process. And this were able to attract another companies as HT Micron and also the design house installed here in Brazil now, like in Porto Alegre as Impinj and Ensilica, for example. So our interaction, our role in the human research formation is very important to attract such kind of industry here for the South Brazil.
Maybe I can add something about the history. Is that when it was started the graduate program on computing here at Porto Alegre, it was composed by professors coming from electrical engineering, computing department of the university, as well some few professors from the physics institute that time. And the first developments in the graduate program was strongly in hardware as well software. No? By the way, it was launched here hardware and software symposium that time. That was finally the channel for the origin of the Brazilian Computer Society later. And it was used that time in the master program because we had no PhD that time. It was end of year 70s, no? And the master was like a PhD that time. It was about 3-4 years a master, no? So, and then a large set of them finished by some prototypes. And this procedure gave the origin to a significant set of companies here in our state. So companies like Igisa, Digitel, Altus, and LSI, and several of them are still running here. No, so companies also related to communications, to industry automation, and so on. And then when a large set of professors and students went to Igisa, that was a computer manufacturing. Then we had a discussion in our graduate program that time what would be the next step to help the industry. Then there was an effort to send the professor and the students to do a microelectronics PhD abroad. And then when these professors and the students start returning by beginning of years 80s, no, then it was started the group of microelectronics, and then there was some actions also to spread out the knowledge to other universities in the region. So something interesting nowadays is that we have research groups in microelectronics in several universities in our state, and this is a nice nice outcome that we have. That is the state in Brazil with the largest research production, considering publications abroad. I can say that maybe 80% of the publications done by Brazilians in international conference and journals are from researchers from our state. No? So, and this was this incubation of several companies that time. Also nowadays, with this amount of people with the skills in the field, also was one of the reasons that in Porto Alegre now we have some companies related to microelectronics, like in Silica, Thiago already talked about, no, and in Pinch, but also Silvaco and Rio Intent. And close to Porto Alegre, there is a package company that is a joint venture with Korean people. The name is HT Micro. So all the environment here related to the field, the origin was the development of human resources with skill in the field since a long time. So let me see if there is more questions here. I see no more questions. So maybe I give the floor to Professor Mambo and to Thiago to the final comments about the education. Thiago?
Fidel just asked me here in the chat how the students from Kenya can apply to Rio Grande do Sul and the for graduate program in microelectronics. And I just answered that we have all the information about the our courses and how to apply in our website. We have our website, if I'm not wrong, it was in my slides. If not, it's easy to find. You can look for PG Micro at Google, and probably it will be the first site. And that we have a version of the main information that is also in English and also in Spanish. So the students from abroad can easily find all the information that are needed, as well as the contact of the professors, and also the my contact as coordinator of this graduate program. So feel free to get in contact if you want more information.
Yeah, the courses here are normally done in Portuguese, but when there is a student from abroad, we are ready to do the courses in English also. So
yes, of course.
Maybe this could be also a question, but and everybody is welcome here, no? So and anybody from anywhere can apply to the graduate program here, and as being a Brazilian, so there is no difference, no, when there is the applications too. So, Professor Mambo, you want to say some final comments?
Yeah, thank you, Prof. Ricardo, and thank you, Prof. Tiago, for the good presentation about microelectronics. Yeah, like I said earlier, we look forward to working together so that we can grow the skills of our students and staff members, both in terms of research and innovation, and also applying that research in our teaching programs. Because what is driving the industry today and what is making graduates who come from the universities employable is the kind of soft skills that they attain from the research that is done by the research that is done at the university level, and also exposing them to matters of innovation and creativity. This is what drives Silicon City. We have an equivalent here, which is Konza under construction. Part of it is operational. And these are areas that if we collaborate with giants like you, we could grow them into the levels that you have already attained. Yeah, that is my final comment, Ricardo.
So, thank you very much, Professor Mambo. It was nice to meet you, and we hope to see you in person in a near future, no? And we will be great to have a in-person workshop next year.
Absolutely, absolutely.
Yeah,
Yeah, I
thank
would
you
love
very
it as well.
much.
Thank you too.
Yeah. So, do you have some other comments, Tiago?
No, just thank you again, Ricardo, for the invitation, and thank you, Professor Mambo, for your presentation too. It will be a pleasure to give more information if you need, and to work with you in the near future. So thank you.
Thank you. I don't know if
Thank you.
Fidel has any comments.
Hello, everybody. It's been amazing. I don't have any comments. I'll definitely reach out to Tiago in case students ask. And like Prof. Ricardo has said, I think we should now start doing physical workshops because I've really enjoyed the session so far. Thank you.
Yeah, I think we can start a great collaboration. I think we have very similar problems in Latin America and Africa, no? So it will be nice to start a strong collaboration between
Yeah,
Latin American countries and Africa countries, no? And
yeah,
so
definitely.
okay, so now we can go to the next session. So we have now a presentation by Professor Fernanda Castellmit that is about radiation on electronics, ASICs, and FPGAs. So, Fernanda, welcome. So, you needed to share your slides.
Okay, I will share. Let's see.
They are in PDF or they are in...
They are in PowerPoint.
Okay. So, you have to share your screen.
Okay, can you see my screen?
I can see.
Okay. Okay, good morning.
The
Thank you
floor
very
is
much.
with you. Thank you again, Fernanda, for accepting to participate into this workshop between Kenya and the Rio Grande do Sul. And the floor is with you.
Thank you very much, Ricardo, to invite me for this workshop. So I'm a professor at URGS since 2005. I have been working with radiation effects in integrated circuits and fault-tolerant techniques for these devices, like processor, programmable devices, And this talk today is very introduction. It's only about radiation on electronics because we had only 20 minutes, yes. And it's just to give the problematic, okay? So we will discuss a little bit the problem, and then, of course, if there is interesting, we can have other talks and discuss more in the future about the fault-tolerant techniques and the test methodology that we currently do. So we all know that the electronic is getting more and more complex, okay? So here is just like an example that on space, we are worried about the well-behaved as well circuits operating correctly on space in satellites, in more recent in CubeSats, or in missions that are going to explore other planets. And on Earth, we are worried about circuits that operated in vehicles that require high reliability, like airplanes, self-driving cars, drones, trains, servers. So we needed to worry about these circuits more and more. So first, I would like to talk a little bit about the radiation environment. So the space environment, it consists of various particles that can interact with the digital integrated circuit, causing undesirable effects, okay? So the main categories that we can actually divide these particles are photons and neutrons and the energetical particles. The photons and neutrons, they have zero mass, okay? And they are electrical neutral, as we know, but they interact with the material. And then this is very important to search and to research about the material to reduce the secondary effect particles once these photons or neutrons hit the material. And the energetic particles, as we know, the charged particle, they interact with the silicon atoms, causing direct excitation. And this will cause transient faults, as we are going to discuss. So if we look to the space, and more considering our planet Earth, yes, we have many belts, okay, that are called the Van Allen belts. And these Van Allen belts, they have protons and electrons that are trapped in these belts. So any mission that concerns about satellites, we need to worry about the satellites passing through these belts and interacting with protons and electrons. Then, after these belts, we have mainly heavy ions trapped in the magnetosphere, cosmic rays, protons and heavy ions, and also protons and heavy ions that come from the solar flares. So we have a big cocktail of atoms that we needed to worry about. What is the motivation? Why we need to be concerned about that? So we know that the digital technology is actually evolving. So we have higher density device, we have faster devices that are operating in higher frequencies. We want low power because of the battery. In satellites, we have a big issue about power. We want the next and next technology comes with reduced and transistor dimension. And in some application, we really want very low power supply. So all these make the circuit more susceptible to this interaction of the charged particles. And this is a problem because it becomes more vulnerable. Of course, there are many different technologies that I'm not going to address today, okay, that wants to reduce this effect, like the SOI, some FinFET with new depositions of materials, want to reduce this susceptibility. But the susceptibility is not zero. So if you wanted to design your circuit or select components to some high reliability applications, we need to be concerned about that. Nanometer technologies are potentially more sensitive to these effects and also in atmosphere neutrons. So old technology, we are not concerned operating on Earth, but now the new technology, we also need to concern about radiation effects operating on ground level. New materials and technologies may be less susceptible to ionization, but they needed to be qualified and tested. For the terrestrial environment, the main source are alpha particles and neutron interactions with the silicon. So, because when neutron interact with the silicon, it produces secondary particles, and these secondary particles can ionize the material. So alpha particles are emitted by naturally occurring radioactive isotopes. They are generated by impurities. So in the past, in the 80s, in the 90s, there was some research that detected, okay, this package is made by a material that can produce a lot of alpha particles when neutrons interact with them. So actually, the silicon, the dye, was less susceptible to faults before packaging than after packaging. So these all researchers have been discovered all these effects, and nowadays they look for materials that have very low emission of alpha particles. But even today, yes, low alpha compounds in packaging material have sufficient alpha particles, and we needed actually to analyze that. This also brings a concern about when you are doing testing, qualifying, that we don't want to remove the packaging, in this case for neutron, because we wanted to see the effect of the neutron passing through all this material of the final, let's say, system. So the neutron, they do a shower of neutron particles in the atmosphere until it reaches the ground. So we are always here, yes, under a shower of neutrons. But depends about the altitude that you are, you can be susceptible to a higher or a lower flux of neutrons. Okay, so it depends. So for example, here, the peak of neutron is around 2,000 meters. Of the altitude. The aircrafts, the standard commercial aircrafts, they usually they fly in 10,000 meters. It depends, yes. But so it depends where you are and where is the electronic that's operating in the aircraft or the drone, yes, or even in the satellite in a low orbit. You needed to be concerned about different flux. At the ground level, the flux is much lower, but it still has an impact in the electronics. At the sea level, usually we have 13 neutrons per centimeter square per hour. So for the radiation effect problem in space application or in high reliable application, what can we do? Focusing on Earth applications mainly, or space applications, we can use radiation hardened device. So if you look in the internet, you look for companies, not many, but some of companies on the planet, they focus on radiation hardened devices. So these devices were designed with specific fault-tolerant techniques or fabricated in specific foundries to be more tolerant to radiation. Or another option is to qualify commercial circuits by radiation ground tests and see if they can operate in the target environment. Using radiation hardened devices, we often solve radiation effects problem, but what's the problem? The problem is that they are more expensive than non-hardened device. So, for example, you can buy microprocessors that are radiation hardened by few $1,000 or even $30,000 or more. FPGAs that are red hardened also, they can cost more than $30,000. So if your final application requires a large number of microprocessors or FPGAs red hardened, the final aircraft or the final satellite or the final server will cost much more than if it was designed with commercial devices. Not every device is available in a hardened version. So if your application needs a very state-of-the-art device, GPU, very high-density FPGAs, or very high-performance processors, maybe sometimes they are not available in hardened versions as well. So this is a little bit the same, that the hardened devices are usually fabricated in older technologies, not always, but the majority they are, and they have sometimes sale limitations. They have, for example, the ITAR, that some devices they cannot be exported for all the countries in the world. So an alternative solution is to carefully select candidate device to choose only those which are robust enough for that environment. So current policies of space agencies, and not only space agencies, but many companies that develop high reliability devices, systems, they look for commercial off-the-shelf technology to build their system. So we call this COT circuits. And these COT circuits, they are the state of the art, but they need to be qualified and sometimes to implement some fault tolerant techniques to make them less susceptible to radiation. So the question is how to manufacture a robust system with standard commercial process. We are not going to answer this question today because then will be many hours of talk, okay? But the idea is that we need to understand better the phenomena and then later on invest in qualification, in tests, and fault tolerance techniques. So the radiation effects by radiation, they vary according to where your application is running, the kind of particles, and they can do ionizing damage, they can do single event effects, and so on. This I'm going to explain better now. So the main types are single event effects, total ionizing dose, displacement damage, and spacecraft charging. We are focused today in the first two, single event effects and total ionization dose. So single event phenomena can be classified in three effects, okay? First, the ones that are soft error. We call soft error because they are transient. So they can be single event upset or single event transient that I'm going to explain today. Then later we have single event latch up, which can be soft or hard error, because sometimes the circuit can recover from a latch up, sometimes not. And we also have the single event burnout, that is hard failure, and your device is permanent damage. Hard errors or single event latch up are doing shorts between ground and power because of the ionization, and they cause permanent functions only if they can be recovered very quickly. But usually what we have is a kind of circuit that detects very fast the increase of the current. It turns off the device to avoid the latch up. So here we have a figure just to explain that if we have ionization in the implant NP and goes to the substrate, and for a short period of time we have broken these barriers of each region of the transistor fabricated in the substrate, we can have, for a short period of time, a connection between the ground and the VDD. So in this case, we have a current that can provoke the damage. For single event transit and single event upset, which are more concerned at ground level as well, I quoted here one of the definitions from the NASA site, that single event upset is a radiation-induced error in microelectronic circuits caused when charged particles, usually from the radiation belt or from cosmic rays, lose energy by ionizing the medium through which they pass, leaving behind a wake of electron hole pairs. Okay, so this is the definition I'm going to show in figures of the phenomena of this transient ionization. Okay, SCTs are transient errors and are non-destructive. So what they say is that a reset or a rewriting of the device results in the normal device behavior after the event because it's transient, and a single event transient may occur in analog, digital, or optical components and may have effect in surrounding interface. SCTs typically appear as transient pulse in logic that I'm going to show, or in memories. And when they occur in memories, we call bit flips or single event upset. So what we have, each transistor, NMOS or CMOS transistor, these also for FinFET transistors, we have the junction, the NP junction or PN junction. In this case, when we have a energetic particle that hits this junction and has enough energy to deposit, to ionize and deposit some energy in this stroke node, okay, this actually provoke a track of electron hole pairs. And this for a temporary time can charge or discharge just this node. Why do I say charge or discharge? Because it depends if it is transistor NPN or PNP. Yes, because for example, in this case, if you have a NMOS transistor, the substrate will be at ground at 0. So in this case, we are going to discharge this node. If you have a PMOS transistor, the substrate will be in VDD, and if we broke this barrier, we are going to temporarily charge the node. Either way, discharging or charging, we are provoking a transient current pulse, which will be seen as a glitch. So, depends about the particle as well. If it's a heavy ion particle, or if it's a proton, we will have different shapes of ionizations. And so we can actually, protons, for example, can interact with the other nucleus of the atoms and provoke different tracks. So they increase the probability to ionize more than one junction. And then we have these multiple bit transients that I'm going to show later, okay? So what we are concerned at system level, we are concerned to avoid failure, okay? But to avoid failure, we need to be concerned in all the different steps until we reach the failure, because the goal is never reach the failure if possible. So first, we have the ionization, very on the left. This ionization, and as we are going to see, may or may not provoke a transient current. Why? Because this ionization can have not enough charge to discharge or charge that node. So maybe the glitch, that is the transient fault, may be seen or not seen, okay? If this transient is enough to be seen in the circuit and to be recognized as a signal in the circuit, it may or may not be captured in a flip-flop. This transient can occur inside a flip-flop. So if it's captured by a flip-flop or it's happened inside a flip-flop and I see a bit flip, this means that I'm seeing a fault effect. This means that the data that I have stored in my design, in my circuit, has changed. This is not permanent, but this data is wrong and may be processed wrong and maybe put my design in a wrong state or may provoke a wrong answer. So this is seen as an error. And this error may be correctable, yes, by reset, by redundancy, by masking. And if I cannot correct this error, or if I cannot mask this error, then there will be a failure. And this is usually bad, a catastrophic event that we wanted to avoid. Okay, so we need to be concerned all the time that not all fault is going to become an error, not all error is going to become a failure. This is the process of understanding the fault effect and understanding error and to understand the failure. So for the collected charge, depending of the circuit, the technology, the transistor size, the charge energy, we are going to have different current amplitudes, different durations, and different shapes when there is a ionization, okay? So we can see in this figure here that depends about the particle and the transistor, we have a different energy that is transferred from the material, and we have different shapes of currents. These different shapes of currents can be easier to propagate to the circuit or not. So if you have a very low amplitude transient pulse, maybe this pulse is going to not be recognized in the circuit as a signal. And then we don't need to worry about this fault. This picture shows an inverter, okay? So we have here an inverter logic gate composed of an NMOS transistor and a PMOS transistor. Let's suppose that I have logic 1 in the input, and then consequently I have 0 at the output. So this NMOS transistor is on, operating on, and the PMOS transistor is off. The susceptible nodes for ionized particles are the drain of the transistors that are in the off state. So I have this drain here as a susceptible node of my device. So if a charged particle hits this node and can deposit enough charge to have this track of electron-hole pair enough to provoke what? The PMOS transistor, the substrate is connected to VDD. So I will temporarily charge this node. So there will be a current coming from VDD to charge this node. But this transistor here is on. So this transistor will take this node and try to pull down to 0 again. But this will be a fight, a transient for a short period of time. So this node will be charged and discharged by, again, to these NMOS transistors that is operating at on, okay? So what is important is depends about the particle, depends about the transistor size, depends about the materials. This transient, okay, will occur in different shapes and different amplitudes. Now, if we take a look this in a circuit, okay, this is just example that, for example, I have some register, I have some combination logic, and then I have a flip-flop at the output. So in this case, my fault can occur directly in a flip-flop of my register, provoking a bit flip, or can occur directly in a drain of a transistor that compose my logic gate, provoking a transient pulse, and so on. We need to worry about, at high level, mainly of bit flips that occur in memory. All the caches composed by SRAM, DRAM are also susceptible, many types, even flash, okay? Flash are less susceptible than SRAM, but still there are some susceptibility. And bit flips can occur in register, memory, flip-flops, and so on. For the SU modeling, it's very important if we are a designer that is designing flip-flops, combinational logic gates, to analyze the susceptibility of this design at electrical simulation level, for example, by modeling the transient fault. So it's well known in the literature that it's possible to model this transient current as a double exponential curve when we set these parameters that correspond to the rise and fall of this current shape. And then we can simulate the injection of this transient current in the susceptible nodes and to analyze how these logic gates will behave under these transient currents. Okay, and then with different current shapes, we can model different charges for a current period of time, and this will correlate with different particles in different environments. For the combinational logic, what we need to be concerned is that it depends about the transistor size, depends about the fan-out, the charge that is already connected to that node, okay, the capacitance that's connected to that node, to see how large is going to be the transient current. Okay, so it depends about the node, it depends about the number of transistors, the capacitance of that node, to see which will be the critical charge that must be deposited in that node to provoke a transient current pulse. Now for total ionizing dose, I will come back to more to SE later, but for total ionizing dose, they are mostly do electrons and protons. So we needed to be concerned about total ionizing dose with for more the aircrafts that goes very high in the atmosphere. Satellites, for example, are very important us to qualify and to see how long each circuit will correct operate after absorbing a certain amount of dose. In either case, total ionizing dose is measured in terms of absorbed dose to the matter, okay? We say rads, okay? And then its material depends as interaction between the particles on the atomic numbers, density, and others. So it depends about the material, depends about the packaging, and all the surroundings as well, okay? The main radiation dose is from solar and electrical particles and the passage through the South Atlantic anomaly, which I'm going to show. For example, in low orbit LEOs, the main dose source is from electrons and protons. In the geostationary Earth orbit, the primary source is electron and solar protons. So we have the South Atlantic anomaly, which by this figure you can see that reach parts of Africa as well, but then very much more lower level. But this area here on the globe is continuous changing, and it depends about the time of the year. It goes more for the east or more for the west and so on. But what is that? This is a depletion of the magnetic of the globe, which makes this region to concentrate more energy particles. So it has a more concentration of electrons and protons that goes down in the altitude of the Earth. So airplanes that goes through these areas, satellites that low orbit that pass through this area, they interact with a higher flux of electrons and protons. And so they have a higher probability to have single event effects and also total ionizing dose. Usually that depends about the orbit. For example, a circuit may receive 5 kiloreds in the silicon per year. This is a lot or is not? It depends. For example, the new technologies, usually they can work very well up to 20, 40, 60 kiloreds until we see some degradation in the operation, or even if the circuit dies. Old technology or technology based on flash or some specific analog circuits, they are more susceptible for the radiation absorbed. So sometimes they can operate up to 10 kiloreds, 15 kiloreds. So it depends about the component. Also, this total ionizing dose, it can be observed in nuclear plants or in some accidents or attacks in bombs, of course. So circuits, they can degrade also if they have this very high impact of radiation. And then we are talking about this effect that is the total ionizing dose as well. So what does the total ionizing dose? The total ionizing dose increase material degradation. As total ionizing dose increase, the material degradation increase as well. For example, solar cell output will decrease, which is important for satellites, for example. Long-term exposure can cause device threshold shift, increasing device leakage and power consumption. So if you test total ionizing dose on Earth, for example, with a cobalt-60 source and so on, we can see very clearly that the current of the circuit increase after some dose, and to reach some point that the circuit cannot operate anymore. If you analyze the digital design, we can also see that usually it comes with a degradation in the delay. So if the device could work properly, 500 megahertz or 1 gigahertz, after a while, you needed to degrade, reduce the frequency in order to keep operating the device until a point that you cannot operate the device anymore. Total ionizing dose effects may be mitigated using radiation-hardened device and shielding, but as all you know, there is a limit. For example, when there was some accidents in the nuclear plant, for example, and there was some robots to go inside the nuclear plant to try to do some work to reduce, some parts of the doors, close the doors, or interact with the machine. You can see that these robots could operate just in some hours, sometimes some minutes, because it depends about the amount of radiation that the circuit is connected. Even not shielding is enough. But of course, when you talk about the space, that spacecrafts or satellites or international planets mission, yes, we are talking about some dose that is not so high, that goes for many, many years. And we usually work with shielding and some specific process in the technology that reduce and to increase the life of the device. Now, coming back to single event effects, so let's talk a little bit more of these two phenomena, the one that is in the register and the one in the combination logic. So if we are taking a look in the flip-flop, so this is a latch. What happens? In a latch, the standard latch, we have two inverters, one inverter here, the other one here, connected as a loop. So if I have 1 in this node, I'll have 0 in this one. See, 0, which brings 1 to this output, with 1 here, and we have this latch. What happens if I have a particle hitting one of these susceptible nodes? Which are the susceptible nodes? The transistors that are off. Here, the drain of an off transistor. Here, the drain of an off transistor. NMOS, PMOS. So let's see. I have a particle that hits this. Then I will have a ionization broken here, this barrier for a transient period of time, NP, for example. So in this case, I will discharge this node for a small period of time. But see, this node was at 1. I will discharge because I will connect for a short period of time this implant N to the substrate P that's connected to ground. So in this case, I will propagate my transient, and this transient will make this node 0. Then we'll turn on the PMOS, turn off the NMOS, will make the output 1. This 1 will turn on the NMOS and turn off that PMOS. What happened here? We have a bit flip. We inverted the original value of this latch. And this is the most common phenomenon of radiation effect that is observed on Earth or on space. The bit flips can be multiple bit upsets. Why? Because of the particle incident angle, because of the transistor disadvantage, voltage supply, and so on. If you take a look in the literature, you can see that nowadays the memories, they have interleaving for the bits up to 7, because we can see very easily up to 7 multiple bit upsets. This means that a single particle can hit up to 7, up to 8 latches at the same time. So mitigations are done. Usually what? These interleaving bits and error correction codes, yes, to be able to cope with these bit flips, multiple bit flips in memories. We can analyze at device simulation, which is very interesting to see how the ionization occurs in the substrate, to see how they propagate, and to see how long it takes to the substrate to recover the original charge. There are many hardened memory cells. The hardened memory cells have been developed. There are many that were developed in the 80s, in the 90s, and they are still well known as DICE cell, heat cell. So new designs can use these hardened memory cells to make the circuit less susceptible to bit flips. Okay, and these cells also can have some techniques implemented in the layout. The problem is that because of the scaling is that we are reducing the node, multiple bit upset is really a commodity nowadays, because the charge, the area that the charge can hit is still the same. But now in the same area, sometimes we have many transistors. Also, we need to see that the duration of the pulse comparing to the clock periods is becoming more and more the same, because we increase the frequency. Now we work with 1 gigahertz to 3 gigahertz, and this brings a period of 1 nanosecond, half of a nanosecond, or 1/3 of a nanosecond. And how long is this SCTs that have been observed? So sometimes the SCT is the same order of magnitude of the clock period. So coming back from the combinational logic, what can we see? In the combinational logic, as I showed before, you have the SCT in the susceptible node, okay? But not all the SCTs are going to be seen as a fault in the circuit, which is very good. Why? Because these SCTs that will occur in the logic, they can be logical masked. Sometimes they are in a node that's not important to be passed to the output, so we are not going to see. Sometimes they are electrical masked, because the SCT is so thin or have so low amplitude that there is not enough strength to pass through the path. So it's a negligible pulse, is not going to be captured. And also sometimes the SCT propagates to the circuit, but it does not reach in a time that's going to be captured by the flip-flop. So it's also not important. So we have many SETs that are not captured and not seen as a fault, okay? But we need to see that because of the evolution of technology, nowadays it's more and more common to see the SETs that are going to propagate to the logic and not be electrical masked anymore. So, for example, this is an old technology. In this old technology, we could see that the SETs would degrade better after a number of inverters in series, for example, okay? So here is a struck node. After 2 inverters, F4 inverters, it has already decreased the size of the SETs. But if I have a stroked node with an SET that is strong enough, it's going to pass through 4, 6, 8 inverters, and it's going to continue stronger. So this is more what we see nowadays in the new technology. Because usually if there is an SET, the SET is already strong enough. Okay. Also, if we work in a higher frequency, we increase the chance to capture an SET. Okay, so this is probability, because if we are capturing the SETs by a latch, in this case, a dice latch, to don't see the susceptibility of the latch. So if we increase the frequency, we increase the probability to capture the SETs. So now working in 1 gigahertz, 2 gigahertz, 3 gigahertz, we increase the probability to also capture SETs. Because the SETs are getting more close to the size of the clock period. So this is a classic figure that is here from many years now, but it shows that once you cross the clock frequency barrier, your errors are not only due to SUs anymore, but they increase because you are capturing more SETs. Okay, other challenge that we need to see is the fan out. For example, each time you have a node and you divide the node in 2 paths, this SET can become 2, okay? So we are going to see multiple errors in your device. What happens if processor? So this is concerned because, but this is for another talk, okay? But then, for example, we can consider bit flips in the memory, bit flips in the registers. So bit flips in the memories can affect the data flow error. Usually you are going to see errors in your response. If you have bit flips in the registers that are important for the control path, you are going to have usually timeouts, hangs. Okay, so we can see silent data corruption, which are wrong responses. We can see timeouts, hang, and we needed to cope with these effects. In programmable device, what happened? Programmable device, FPGAs, they can be programmed by antifuse, flash, SRAM, but we can see as a programmable matrix that's composed usually with lookup tables, flip-flops, connections, and a lot of memory cells that are going to program, configure this matrix that can be programmed by SRAM, flash, antifuse. The antifuse and flash these are not susceptible at all to radiation. Flash are very low susceptible to radiation, but SRAM are very susceptible, as we have seen the bit flip in the latch. So, for example, like in the programmable device Zinc, for example, we have embedded processors and we have all the configuration matrix. So we have a possibility to have faults in either parts. So here is just an example. For example, we have this SRAM-based FPGA. When you have a lot of latches to configure the FPGA, we have a soft core processor, which is designed and customized using the CLBs. You have the hardware processor, and you have all the logic here. Then if a bit flip occurs in the configuration memory, you can have a soft error in soft processor. But this error, this effect is persistent because it's a bit flip in the configuration memory that configures this processor. So if this processor was a RISC-V, now it's not a very well implemented RISC-V, but it is a RISC-V not well implemented in the FPGA, which is always with something wrong. So this has a persistent effect that's going to be correct only when we reconfigure the flip-flops, the latches that configure the FPGA, the bit stream. We can have SUs, SCTs in the logic itself, then will be transient. And we can have multiple faults in the configuration memory, which will have persistent effects in the designs that are implemented. So what we need to do? So we have a lot of different devices, microprocessors, GPU, FPGAs, and so on. If we want to use commercial off-the-shelf GPUs, FPGAs, microprocessors, we need to qualify them. This means go to radiation in facilities on Earth and test them and see how they behave under protons, under electrons, under neutrons, under heavy ions. Then once we understand well how they behave, we are going to apply mitigation techniques that better suits these devices. You can implement in software or in hardware. Yes, and then this will need the qualification again until we reach our goal, okay? And so we have done the fault injection methodology to analyze that, simulation, and we go to facilities in Brazil or in Europe or United States to qualify these devices under radiation and to understand better. And for the mitigations, we do redundant instructions, redundant register, critical register, approximate computing at software level. In hardware, we can also use approximate computing. We can use redundancy by triple model redundancy, duplicate with comparison, use dedicated voters. We can modify topologies and configurations, and so on. So it's a set of mitigations that will work better for your device to reach the purpose. And that's it. Yeah. So thank you very much. What was first more focused on the radiation effects to show better the problematic.
Okay, thank you very much, Fernanda. So we are open for questions now. So if you have any question, please do it as soon as possible by using the chat channel. So maybe, Fernanda, you can talk a little bit about the nanosat that is running now
yes.
more than 8 years, no, with
yes.
some sequence
Yes. So we have worked in a nanosat, a CubeSat, 10 centimeters by 10 centimeters, a cube, that was launched in 2013. So we worked in the payload that was composed with a flash-based FPGA, composed with a soft-core processor, a MIPS, that was running some applications. And this CubeSat, nanosat, is in orbit since 2013. And because of the components, we have qualified the components before, and we saw that for totalizing those, it could reach a very high level. It's still working and it's still sending the data. And then later on, we worked in the nanosat BR2, that is a 2 cube satellites. So it's the double of the size. And for the payload, we also work with FPGAs. with the SRAM-based FPGA from Xilinx, and then flash-based FPGAs from Microsemi. And also, we have qualified the payload. We have tested with the onboard computing on Earth, and the satellite has been launched last year on March. Unfortunately, there was a problem in the onboard computing that actually the communication between Earth and the satellite has not been established. So we could not collect the data from our payload, yes. But before launch, we have tested everything for the payload, and it was nice. So it was a very good project.
Okay, thank you. So I see no more questions now. Anyway, we are late in the schedule. So we had scheduled a 10 minutes break, but as we are late, I think we are going to do just a 5 minutes break in order to get also Professor Bumpy in the StreamYard tool to upload his slides. So next session will be about industry, and it will start by a talk with Dr. Latif Kerono, and then another talk by Professor Sergio Bumpy. So see you in 5 minutes. So Dr. Latif, you can already put your camera. Hello, nice to meet you. So here are your slides. I think your microphone is...
there. Can you hear me now?
Now it's okay, yeah. Yeah.
Fantastic.
So we start 5 minutes later, so 11:15, just to give time for the audience to get a coffee and I also inviting Professor Bumpy to already upload his slides because he's going to talk after you. So So, Dr. Latif, it's nice to meet you. Thank you very much for joining us for this workshop today. So Fidelo was going to introduce you, but he had to attend another meeting now. So, and I did not receive your CV, so I cannot do a better introduction.
Don't worry, I have it in the slides, so it's okay.
Good,
it's okay.
good.
Yeah.
So let's wait more 2 minutes, then we start the session.
Okay, not a problem.
No. I think this workshop can be a start of some nice collaborations, no? So I think Fidel is back.
Yeah, absolutely. I think listening to what has been said so far, it's Kenya, we're about, let's say, 2 decades behind where you were. So we'll learn a lot of good lessons from you, and then see how we can
I
use
think
those lessons to work.
we also have a lot of lessons to learn from you. I'm sure.
Yes, absolutely, absolutely.
Okay, I don't know. So it
So
might be late, but yeah. So that is Latif Cherono. He's the manager at Gearbox Europlacer. He does Gearbox Europlacer. We'll talk about it. They basically do this. I think one of the largest PCB assembly, and they also do some PCB manufacturing in East Africa. So he's gonna talk about it. We have been doing events with him, especially when CASS started in Kenya last year as CASS Kenyatta University student branch. And he's also a CASS member, and he's part of the CASS Kenya chapter that is executive committee. So welcome, Latif. We are happy. He studied in the US, so you might notice from his dialect, but he lives in Kenya. He doesn't live in the US. Yeah, welcome, Latif. You can, if there's anything I've not said, you can maybe add to it. Thank you.
Sure, sure. Thank you very much, Fidel. Thank you for that introduction. So I'll just quickly go through my slides, a little talk about Gearbox Europlacer, what we do, and then about the electronic manufacturing sector in Kenya, where we've come from and where we're going, and the opportunities for us. So we'll begin. So again, Latif Cherono. My background is actually mechanical engineering. Grew up in Kenya, went to university in the United States, and that's where most of my work has been, manufacturing engineering in the automotive sector, and then also in the electronic manufacturing sector, also doing a lot of Lean Six Sigma consulting across Kenya and South Africa. So a funny story, when I was moving back home from the United States, I didn't think I would do electronics manufacturing ever again. I just thought I would go into consulting in Lean Six Sigma. But an opportunity came around 2016 when I saw the founder of Gearbox, Dr. Kamal, tweeting about PCB fabrication, and I was amazed. I said, "This is what I do." And we started that conversation on how do we bring electronic manufacturing at scale to this part of Africa, East Africa. And 5 years later, what we have now is Gearbox Europlacer. So I'll explain a little bit about what we do there, and then go back, talk about the industry at large. Okay. So we're what we call a high mix, low volume electronic manufacturing service facility here in Nairobi. So our goal really is to provide two things. One, we want to provide quick turnaround EMS services to the local community. So this community goes all the way from mature companies to startups to innovators to young engineers working on their first projects. And also we want to catalyze this industry because we are at the start, at the beginning of creating this sector, and the more that we engage with the sector, we realize that it is really growing, and it's growing quite fast. So the reason for us to be here and to set this line up, what we want to do is ensure we have the maximum transfer of value on the design of electronic products, the manufacture of those electronic products, the distribution of those products, the after-sales service of those products, keeping all those jobs and knowledge transfer here locally. And from there, we can then build into something that is quite remarkable, not only in Kenya, but across East and Central Africa and into the rest of the continent. So how will we do that? Really, our vision And our mission is we want to stimulate the design and manufacture of African design intelligence solutions that solve African problems. Now, why is this important? When we're talking about electronics manufacturing, our key competitor, or the incumbent in this situation is China or the West or developed markets. So if you're trying to replicate what they're doing, you'll find yourself competing at cost, at technology when you're not ready to do that. So the best place to start is where you can actually solve the problems that you deal with every day, and that's what all the young engineers on this webinar that we've been engaging with over the last few years, the members of CASS, IEEE Africa, we have problems in Africa that technology can solve. So we start from there, actually creating and owning that IP of those solutions, creating best fit solutions, and then propagating those solutions across the region, across Africa. And as was said earlier in this webinar, some of the problems we face in Africa, some of the problems that are faced in Latin America. So, some of these solutions can go across, right? So the PCB that you see on the right of your screen, that's actually a home automation PCB designed by a local engineering firm here in Kenya, manufactured at Gearbox Europe places. So you can actually say that is completely made in Kenya, solving a uniquely Kenyan problem around home automation. So even in home automation, we're looking at that from a purely African standpoint. When we say home automation, what do we mean on the continent? What is that? What does that require, and what do we need to do there? Okay. So the capability we have in our facility currently, we can do close to about 600,000 IoT devices per year, with a capacity to grow over the next few years or so. So when you're looking at the market of IoT devices in Kenya, we're probably at around 1 million devices a year as far as the market is concerned, but it's growing extremely rapidly. So we're looking to see how we can transition those IoT devices that are being imported to being manufactured locally, designed and manufactured locally. Right? So this is our SMT line that we have here in Nairobi, right up to the world-class IPC standards with regard to ESD, dissipation, all the IPC standards for manufacturing class 2 devices, and then also working to class 3 devices. Okay. The services that we offer, contract manufacturing. So again, providing services for local startups to help them reduce their product development time as they're going from understanding this is the problem that the market is facing. This is a proof of concept that we think can solve that problem. Then this is the alpha prototype, this is the beta prototype, and helping them reduce that time. Because one of the needs that we've seen is that once a startup has to go back and forth, shipping their designs overseas and then waiting for the hardware to be shipped back home, while it might seem cheap at, if you're, let's say, purchasing the PCB from China, by the time it comes back home and you actually add the landed cost, and then you add the time it took to get your device, it actually becomes more cost prohibitive, And then if you have any issues with that device, if it's not working, and then you have language barriers that stop. Okay, my bad. Okay, sorry about that. I had a phone call, cut the line, but I think I'm back. Yeah, so this, what we're really trying to do is reduce that product development time. The other thing that we're also doing is providing contract design and product development services for startups who don't possess that capability. Also developing our own products and then doing some sort of electronic diagnostic repair. Okay. So you can see from the flow here, from a customer would come to us, they would say, I have a design, can you manufacture it for me? We would then validate that it's ready for manufacturing, and then validate through SMT manufacturing, PCBA testing, and delivery of finished goods, or go through a new product development cycle, which will then lead into manufacturing. And then when we're talking about diagnostics, one of the key things here is understanding that mission critical systems, especially those that are imported from Asia, sometimes they come without manuals, without translation. So when something breaks, it's very difficult for somebody to understand what's the root cause of failure, and then to get that machine back up and running. So this is also other services that we are providing. Okay, and some of the partnerships that we have, from Europlacer, who's our key partner in technology, to the IPC, which is the Global Association for Electronics Manufacturers around the world, to Raspberry Pi. We're a Raspberry Pi design partner. I think the second one in Africa. So working to develop Raspberry solutions based around Raspberry Pi solutions. To the Association of Countrywide Innovation Hubs, and then of course IEEE, the Africa Council, is also a partner of ours. So that is in a nutshell what we do at Gearbox Europlacer. So to put all that in context, I want to take a step back a bit to get you to understand what is the need and what's the reality that we're facing when we're talking about digital transformation. So we all know that digital transformation can make huge strides in economies, improving lives, and that significant advancements. But when we look at the reality, especially when it comes to the hardware side of digital transformation, you know, Africa as a continent is really not involved in the hardware conversation at all. And then when it comes to the creation of the IP in hardware, we're not even in that conversation, period. You know, so if we're going to do that, you know, we must start investing in that technology on all levels, all the way from education up in industry, and really creating a very good ecosystem that allows knowledge to transfer freely across all the stakeholders in that value chain. And I think for me, this is when I was doing the research and saying, you know, should we develop electronics manufacturing here on the continent? This to me was really said it all. You know, so when we look at this shift in the electronics global value chain with GVC, you know, you had the shift in offshoring from developed nations to Asia, of course, seeking low labor. And then in the mid 2000s, late 2000s, you had this shift in nearshoring due to shorter product life cycles. But what we know is coming, and it's already started happening, is reshoring, the movement of advanced manufacturing back to developing countries because of automation. So when in Africa we talk about we have a huge young population that is going to offer low labor, what will that be when low labor is not, you know, a cost? It's not adding any value, you know. So that's why Africa, really, we have this opportunity now to develop this capability around the design and manufacture of electronics, or in this sector. Because if we don't develop it now, in 20 years, you know, why do it? Because we won't have any sort of competitive advantage. So we have to, this opportunity for us is time bound. Okay. And then of course, when we look at what happened with COVID and what it did to the supply chain, and really disrupting that supply chain, saying, you know, if you were lower down the list, you don't have access to the goods that you want, put Africa really at the mercy of other larger economies. You know? So we have to be able to build this capacity to better weather the storm of future disruptions. So again, COVID just showed us this is something that you have to do. Otherwise, you'll put yourself at risk from an economic standpoint down in the future. So let's look at high-tech manufacturing, the need and the capabilities. So the map on the left is a map that shows medium to high-tech value add as a proportion of the total manufacturing output of each country, right? So the first thing that you can see on the map is that no country in Africa has a mid and high-tech value add over 40%. That means most of our manufacturing output on the continent is very low tech, right? So very few countries have 40%. Some are at 30, but most are at no data or 10% or less. So this map really just tells us there's a huge opportunity around the creation of medium and high tech value. And it also doesn't mean that because we're not producing anything, doesn't mean that there's no market. The market is huge for electronics on the continent. It's just that it is all being imported into the country, into the continent. When we look at the map on the right, now this shows where is the capability of electronics manufacturing on the continent. So we have South Africa, at the south of Africa, that has a very well developed ecosystem around electronics, but most of that is for insular use and then export, but not export into Africa, export away from Africa. The next country that has a very rapidly developing capability is Egypt, where Egypt differs from South Africa. Most of Egypt's projects are actually going into Africa. So, for example, Samsung does a lot of their manufacturing in Egypt for TVs, refrigerators, and such, and then these devices then get distributed across into the continent. When you look at Algeria, Tunisia, Morocco, what they are doing is they're doing nearshoring manufacturing for Europe. So European companies have moved their manufacturing to those countries, and then these devices or consumer goods are manufactured there and then shipped across the Mediterranean. So what these countries did was that they actually disrupted the nearshoring hub that was Eastern Europe. When Eastern Europe, the labor cost rose quite high, many of those companies are now seeking lower labor costs in North Africa. So that's Algeria, Tunisia, Morocco. So the rest of the continent in gray, you can see there's no capability. We do have a few examples of developing capabilities. So Nigeria, Ethiopia, Uganda, and Rwanda are doing basic cell phone assembly. And by basic, I mean really very little value add. All you're doing is you're snapping components together, and that's it. But you have to start from somewhere. Where Kenya is different from everyone else is that Kenya now has a capacity to do more technically advanced manufacturing. So we're talking about S&T, we're talking about prototyping of electronic devices. So Kenya is doing that, but more than that, Kenya is actually leading the continent, or excluding South Africa, around the development of best fit IoT devices. So a lot of design work and ideation is happening in Kenya, and I'll talk a little bit about why that is down. So these two maps show there's a huge need, and also shows that capability is coming, is building. But the most important thing that we know in Africa is that we have these regional economic blocks coming. So the first one is the East Africa Community, just based here in East Africa. Then we have another one called the Common Market for East and Southern Africa, which stretches all the way from Egypt down to Mozambique. And then the really big one, which is all of Africa, which is the Africa Continental Free Trade Agreement. So in all of these regional zones for economic blocks, any company that is doing has a high value add of local manufacturing will get access to these markets at very reduced or subsidized costs. So it means that any capacity that is built now will be able to access the African market at competitive rates in the near future. So that again is a positive thing. Here we're looking at a little bit more in depth at 5 countries on the continent as far as medium and high tech industry. So we can see that South Africa, comparing South Africa, Egypt, Nigeria, Kenya, and Ethiopia. And you can see in all of these countries, the high-tech part of the economy of the GDP is quite low. So again, this tells us there's a huge opportunity to leverage growth, which why this call is so important. We need to build the capacity to develop medium and high-tech industry on the continent. So why, if we do this, what are the benefits of using what is known as ADP, or Advanced Digital Production Technologies? So the Internet of Things, which run on machine learning, artificial intelligence, big data, CAD, advanced manufacturing. All of these means that we have better products, improved production efficiency, better energy optimization, all the things that we need on the continent. We need to create jobs. Especially that link up to high economic complexity. We need to have goods that work well with the environment. We need to have better solutions for marginalized groups as well. So these are all the benefits that, again, speak to why this is very important to do on the continent. I hope everybody can hear me. Please, if I could get some feedback, that'd be good.
Yes, it's okay.
Just making
It's
sure.
okay.
Okay, fantastic. So what are the benefits of building this capacity in Kenya? Of course, we're developing the value chain. One of the things in Africa, governments tend to really focus on manufacturing only, as a kickstart to growing economies. However, in electronics, if you just focus on the manufacturing portion, the value add in manufacturing is less than between 15 to 7%. 15 on maybe high value electronics, 7% or less on consumer electronics. So you really have to focus on the front end of that chain, which is the design and creation of IP in electronics. And then the back end of that chain, which is the distribution and after sales and data collection of electronics. That's where the value is. And I think the perfect example for that is a company like Apple, which doesn't manufacture its products, but is one of the most valuable tech companies, if not the most valuable tech company in the world, right? So for us to succeed on the continent or in Kenya, we have to look at the whole value chain. How do you build IP? How do you manufacture locally? How do you distribute it locally? How do you provide the after-sales service to those devices, which then helps you build better devices on the iteration cycle? High skill job creation. That whole chain that I just described is highly skilled. You need highly skilled engineers and designers to create great products and to understand products that will serve the market well. You need highly skilled engineers to manufacture products that will work well in the environment. You need a very highly skilled logistic operations to distribute these devices. And then you need a highly skilled technician force to provide that after sales service. So these are jobs that are at a very high level, which is much more than just the basic assembly of snapping phones together, right? And then when we look at competition, as far as the continent, there's not much, right? So it's pretty much for the taking. So it puts Kenya at, with the right policies, the right collaboration, gives us a head start in making us a location for electronics manufacturing across the continent. So what is our path to get there? Really it's we want to add local content value addition on a map that goes from basic assembly up to full manufacturing. So if we say we started our basic assembly process in 2013, where we were adding maybe less than 10% of local content addition, by 2027, 2030, we want to be on the journey of adding 75% or more. And we can look at two really good examples, two countries that have done this very well. The first being India, which has really transformed its electronics manufacturing industry with very good policies. And then next is Egypt, again, which has also done the same. Now, what I find interesting when I also compare what has been done in Brazil, Brazil started from the education standpoint, saying we need to build the skills required for this industry. Whereas when we're looking at what's happening in Kenya, it's the other way. The industry is looking for products, so education now needs to catch up to what industry needs. So it might be a different way of looking at it. Maybe the research that happens at universities becomes more focused on products or solving the needs locally. So maybe that might be it. But again, this can only happen with very close collaboration between all the stakeholders of industry, the universities, the government, technology partners, and the like, both locally, regionally, and from an international standpoint. So what's happening locally when we're looking at the electronic device market? Even though we use a lot of consumer electronic devices, education, even automotive on the continent, if we were to manufacture any of these devices in the white, these three columns here, we wouldn't own the value of the IP, so our value retention would be low, which means that we would be at risk of disruption, right? If we said a big manufacturing company come to Kenya, set up a manufacturing plant to manufacture TVs, history has shown that there's very little knowledge transfer when this type of solution happens. And when this company needs to move or they find better opportunities, better incentives elsewhere, they will move very quickly. And the country that gave them subsidies will be left with not much. So where we're really focusing on is on this end, on IoT. So starting here where we can create products that make sense, that solve our needs, we own the IP, keep that value retention high locally, and then from here, leverage out to these more high volume products, but again, approaching that from an African standpoint. How do we create best fit products for the local, for the regional African market? One of the things that the ecosystem needs to do and has to do is, number one, educate the government. I would have to say, based on what I've seen from the talk today, the government in Brazil maybe was a little bit more progressive than ours, but this is a journey that we all have to take to educate our leaders in the benefits of this economy and ensuring that we have the competitive advantage to ensure that this sector grows. So what would be great to have is to know what the lessons that Brazil faced in their transition in building their sector, and seeing what we can learn to do the same locally. So I mentioned earlier that Kenya is the regional leader in hardware development, especially around IoT. And why is that? So it's really a confluence of, let's say, I'll call them being at the right place at the right time, right? So the first thing is that Kenya has a very good technology startup ecosystem, ranked fourth on the continent from a report that came out in 2021, right? We also have a very large pool of young electrical engineering graduates, as Dr. Mambo had mentioned earlier. So that skill level is quite high. But I think the platform, or really what has spurred IoT development locally, is that we have mobile payments ingrained in our economy. In fact, I think hardly any Kenyan carries cash anymore. All of us use mobile money. It's faster, it's easier, more convenient than cash or even cards, because it's everywhere. I mean, from some of the street vendor selling vegetables on the street to the banks. Everybody's on mobile money. So this mobile payment is what is the foundation for IoT devices, especially what we're calling pay-as-you-go IoT devices, which amounts for about 60% of all IoT being created locally. And what does pay-as-you-go mean? It means that you take a service that required a huge upfront cost traditionally, and you change that to paying for that product or service when you need it. So a good example for this could be maybe you want to get the cost of a pressure cooker, electric pressure cooker, at $50, $60 might be too expensive for somebody who's living, on a very small sum, But if you change that model to pay as you use, then it becomes more affordable, that they can actually budget for that cost on a daily basis. So that is actually the fastest growing segment of IoT locally. Then when we look at these startups in IoT, the data that we've collected over the last 5 years shows that it's growing 3x in 5 years, right? So phenomenal growth. But also when we look at, what's the maturity of these startups, about half of them are new startups, right? So new meaning 0 to 1 or 2 years, small engineers or people just trying to figure out a solution, building a prototype, in the labs, in the classrooms, at home, trying to figure it out. And then the other half is kind of split evenly to startups who have figured out a solution and they're now trying to gain market traction, to then startups who are scaling a solution that has worked in the market, trying to get it up, and then companies who are mature and serving, tens of thousands to hundreds of thousands of customers. So what this tells us is that there's a path to success. If this graph just said 90% is nascent, then we might say, well, this sector, doesn't look like it's worth investing in. However, the data is showing that there's a very clear path. If you create a best fit solution, you can, and you get it, you get market traction on it, then you can scale it and you can become a mature startup, right? So this is really why Kenya, I think, is the regional leader in IoT hardware development, and it'll grow beyond that with the knowledge that is coming out of this session. So some of the solutions around local IoT that are solving local challenges ranges across multiple sectors. So from healthcare, again, this was mainly driven by COVID, when we realized that from basic things such as pulse oximeters that we couldn't get access to, that we didn't have, to ventilators, and Dr. Mambo mentioned Fidel and his team designing and building a ventilator that is now getting to certification. So you might say, well, you don't have the capacity to do medical devices on the continent. But the interesting part here is, for the first time, the government has actually put the entire value chain as far as certification of medical devices together with innovators and said, what do you need to do to shorten this lead time of product developments in the medical space? That has never happened before, and it's happening now. So using this, we can then catalyze and really create best fit solutions around healthcare. I mentioned earlier about pay-as-you-go. So the device that you see here is a IoT device that is on top of a liquid propane gas cylinder that dispenses LPG based on a user's purchase requirement from their mobile phone. So if I was the customer of such a device, I would say I need to cook my meal today, and that meal would cost me, let's say, 10 cents. I would buy 10 cents worth of gas. The IoT device would then dispense 10 cents worth of gas, which is enough for me to cook my meal. So the irony here is that LPG gas is the cheapest, cleanest cooking form of energy available locally. But because the package that it was provided, meaning that somebody who wanted an LPG cylinder would have to pay $30, $40 up front. And if you're living on $1 or $2 per day, that was unaffordable to you. So then you have to go to higher cost fuel. So you have to go to firewood, you have to go to kerosene. These cost more, they take longer to cook, and they're not clean as far as the health is concerned. So it just ruled out, it's ironic that the population that needed this type of energy couldn't access it, but now due to IoT, they can access it there. So if you take this model and approach it or put it across multiple sectors, really there's nothing that can't be shifted to pay as you go or pay as per use. Another sector where IoT is really growing quickly and creating dividends is in agriculture. So how do we make agriculture more efficient, whether in the greenhouse, whether it's soil monitoring, whether it's providing solar irrigation, based on pay as you go, again, solving real problems using IoT. Then the last one is renewable energy. We all know the emphasis that renewable energy has and what we need to do to mitigate the effects of climate change. So we know that electric mobility is growing fast and is coming on the continent. So a lot of startups are investing in creating the battery management systems, the electric motorbike monitoring systems. And again, this is all bundled in with pay as you go. So because if you're leasing electric motorbikes, you want to manage your assets. You want to, be able to stop the bike from moving if somebody hasn't made a payment. But you also want to understand where these bikes are going, so you can then say, okay, this is where the best place for a battery charging system or charging station would be. So these solutions again are being done by startups locally. To smart power meters. Now, a smart power meter would be a meter that automatically transitions from the grid to other renewable energy sources, be it wind, be it solar, from a home basis to a residential basis to a grid basis, and then energy monitoring and that. So a lot of applications around IoT. The depth is quite big and the breadth is quite big. So a lot of opportunities. And again, solving the problems that we face every day around power, around water, and using IoT to solve that. And that is happening here locally. Okay. So some of the highlights of electronics manufacturing on the continent. So when I was looking at your slides earlier, from the 80s, so Brazil has been doing this, about 40 odd years, maybe 50, and we are coming to about a decade, and this really the start of our journey is the creation of these fab labs within university that Dr. Mambo mentioned. Maybe they don't have much from an equipment standpoint, but it's a start. Then in the mid 2013, 2015, 2016, we had an initiative by the Kenyan government to assemble educational laptops and electoral devices that were actually used last week in our national elections in something called the DLP program. So this is where universities partnered with overseas manufacturing firms. In fact, one of these, PBBH, which is Positivo Group, is actually based out of Brazil. So they helped with the manufacture or assembly of these devices locally. Then the next phase is where we have the electronic device prototyping happening locally. So this is now the fabrication of PCBs up to 2 layers, routing. So starting with a design, actually backing up, starting with human-centered design, then going into the ECAD or EDA for designing the circuit, and then etching that circuit on a PCB up to 2 layers, fabricating it, and then assembling that device. And then that device goes out into the market or goes out into the field for POC testing. And then in 2021 is when Gearbox Replacer came in now with world-class SMT manufacturing. And just at the end of 2021 into 2022, we actually now have a lab in the country that is doing wafer production at a small scale, but it is really happening locally. So I think this would be a great visit from the CTEC team to come and see and help understand where collaboration can happen there. When we look at other manufacturing capabilities, so I'd mentioned this is the assembly line in Uganda, assembling phones. This is the laptop assembly plant in JQuat, which is assembling laptops, similar to more universities, again, assembling laptops. This is a small firm in part of Kenya called Nyeri that manufactures speed governors. So locally designed and manufactured speed governors for the local market. And then Numeral IoT is another local company doing the same, designing and manufacturing best fit products for the local market. So you can see this ecosystem is growing quite rapidly. So from a job creation, we understand that one job in the electronics manufacturing sector will lead to 3, most likely more, indirect jobs. So again, we'll be creating highly skilled jobs in this sector, and then also a well-balanced workforce. So one of the things we're also committing to, and this is how we met with Fidel, is building that capacity and understanding when you're designing electronic devices, what do you need to have? How do you need to understand the end user? What do you need to know from a design standpoint, from a manufacturing standpoint, from an after-sales standpoint? And getting these young engineers to understand that entire value chain, so then they know exactly where they're going to fit and really have hands-on access to. So I think for us, and really this, and I'm speaking for the entire ecosystem here, is that the only way we can grow is that all the stakeholders have to participate. So we have to pull in the commercial, the industry. We have to pull in at the grassroots level, universities, and even take it lower than that. Go to high schools, go to primary schools, and start building that capacity. So by the time a student gets to university, they've already done multiple Arduino prototypes. So they're now ready to solve much bigger problems and get into research into what is a good way to actually build resistors or capacitors. Because I mean, most of these minerals in building electronic components come from the continent, right? But the minerals are mined with very little value add, moved out of the continent, and then brought back as finished goods. So the more of that value chain that we can keep locally, I think the better off it will be for the continent at large. We also need to partner with technology partners, people like Raspberry Pi, Microsoft, Intel, to get that knowledge and that expertise on board, so we can understand best practices. What's the leading methodologies happening out there in the world, and then use that from our context to create best fit solutions. And then last but definitely not least, work closely with industry bodies. So IEEE, policy drivers and the government, bodies such as the IPC, to provide their input on what makes sense for this region to help us catalyze, because we have to ramp up our scale of growth to be able to meet the demand of best fit devices. So you can visit us on the web. You can go to gearbox-europlacer.com or gearbox.co.ke to kind of see what we do. But really, we're looking forward to this collaboration, understanding lessons, understanding maybe what you can learn from us, and seeing how we can collaborate and partner to grow this sector very quickly over the next decade. So thank you very much. It was a pleasure. Thank you for inviting me.
Thank you, Latif, for your very nice talk. So now we go to the presentation of Sergio Bumpy, and then we'll be back for the questions for you and for Bumpy. So
Okay,
Bumpy,
fantastic.
please, can you share your slides?
Okay, let me try. Let me try here, sharing.
So Professor
Hey,
Sergio
good morning.
Professor in the Federal University of Rio Grande do Sul. So my colleague, and he has a great experience in integrating microelectronics and integrated circuit design. So Bumpy,
Okay, are you seeing what I'm sharing there?
No, you are not sharing yet.
I'm sharing Global Electronics Industry Brazil case. Is it showing that?
No, it's not sharing yet. If you have any problem, please, you can send me your slides and then I can upload them.
Okay. Okay, I'm sharing the desktop. How do I share a window?
When you go to sharing, normally you have the option to upload the PDF or to share the screen or the window.
I haven't generated the PDF. I have a PowerPoint screen. Let's see again. Cancel. Okay. Good afternoon. Good morning, Latif and everyone in Kenya, Rio Grande state. We try again. Okay. Thing is, I have to be on the screen when I say okay to this. Is it showing the slide already?
No, you are not sharing yet.
Yeah, here it says that I have to have a two-screen stuff to do it.
No.
I do that in Zoom every time and it works fine.
Yeah. No, just one screen. I only use one screen. So maybe you can send me the slides and then I can upload them.
Okay.
I can convert to PDF, then I can do the upload, then you will be able to control the slides.
Okay, I'll do that right now. Well, the first thing, let me say that I share while I'm doing typing here and trying to figure out. I used StreamYard before, okay, and you just use it fine to share the screen. When you say share, it should say slides, but the slides are not loaded there. Okay.
No, the word slides is to upload the PDF. Then there is the sharing option also, and then normally you can choose between sharing the screen or the window.
Okay. Can I upload the PDFs once they are available?
Yes. When you go to slides, you can upload the PDF.
The PDF slides. Okay. Okay. Well, I really share. I would like to say that I really share the view that Latif just presented. Okay, about how to grow the ecosystem. Right. We have to take a broader look at our position in the global scenario. Okay, and my presentation is going to deal with electronics industry scenario in a global view, South America and Brazil, and then some data on Rio Grande do Sul state. Okay, in our state we produce about roughly 6 to 7% of the Brazilian electronics output in terms of goods, not services. I'm talking about electronic goods. And we employ about 20,000 workers in this industry in Rio Grande do Sul state. Overall, that's about 10% of the Brazilian workforce working in the electronics industry. It's roughly 220,000 people. Okay. And so the Brazilian industry, basically, I was going to share with some data here. Is a case of sluggish, growth. It has experienced sluggish growth in the last 20 years, as most of manufacturing industry, right? Let me. And those data will be. Let's see here. Send file. I'm gonna upload it. And the data will show that Brazil has not grown much in the industrial sector at all since the early 2000s. Okay, it's not captured the waves of growth that has been all over the world. I see Latif's company Gearbox, right, is positioned itself in this market for electronic manufacturing system. The electronic manufacturing under contract is really present in Brazil since this business model started to pick up in the early 80s, right? So the big players like Foxconn, Jabil, and those companies are present in Brazil, and they manufacture all the large volume ITC goods. And overall, Brazil has an electronics industry which has an output of roughly 180 billion reals, which translate to about $30 to $40 billion a year, which has not grown in dollar value since the early 2000s. Which shows it's a sluggish, it's a stagnant industry because it's basically targeting the internal market. I don't know if you see the slides. The slides have been uploaded there. I commanded to be
Not
uploaded.
yet.
Why didn't it say I just selected?
Well,
I can
don't know.
I can send up to 2 files, but I need to be logged in to send it. Okay, that's what it says here.
So maybe you can send to me the PDF.
Well, I'm trying to send it to the protocol here. I say the send file. I chose the file, and I chose open. And what else can I do? It says as a guest user, you are allowed to send, but you need to log in or sign up in StreamYard. Didn't get it?
No.
I just hit send.
Send it to my email, and then I can do the upload.
Okay. So let me open up my email. Yeah, sorry, I should have done that earlier, Ricardo. But I was working in some slides, updating some data, and so on and so forth.
So
And just working as
also waiting for the slides. If somebody have any questions, maybe can do now. So
yeah.
maybe some questions to Latif. That was a very nice presentation. And so one comment about is that here, let's say, when we talk about microelectronics, no, because for us it's clear that we are in a trend without return, that all computing and electronics will be implemented in just one chip. This is more and more. So it's fundamental, mainly for us here in South America and Africa, to be able to transform one idea in one chip. And this is something that was understood here mainly by people from academia. No? That's why the reason that we have few actions in the field is because it was an initiative from the academia, and then this having people with the skills in the field was the reason that we have some few industry here in microelectronics now. So Bumpy, you are sharing now your
Is it showing?
Now you are showing in your screen, you are selecting a document.
Okay. Well, why couldn't I upload directly to StreamYard? I don't know. I've used
I
StreamYard
don't know
before,
what
but
you are doing, but
your
now we are seeing your screen. So if you go to your slides and go to presentation mode, it should work.
is it
Yeah.
showing this
So
title slide? Is it
yeah.
showing?
So just go to presentation mode, please. Now it's
That's the one.
okay. Yeah. Maybe you can also
Good. Thanks.
uh,
Thanks. Thanks.
click
Okay.
in ocultar to take out this small window in front of your slides. No?
Oh yeah, it's showing. It's showing the other way. Excuse me.
So okay,
Is it is it showing the full screen
it
now?
was okay. Now it's not anymore. So go to presentation mode, please. Now it's
Is it?
okay. So go ahead.
Yeah. StreamYard says that you have to have two computers to do screen sharing, which is stupid,
Not
right?
in my
Because it's
case.
okay, but let's use Zoom the next time. Okay, it's easier for me. Okay, global electronics industry. So I'll focus on the manufacturing sector as Latif did, right? So the global view electronics industry, I totally agree with the flow that Latif already showed. So in the electronics global industry, we are seen as a market. The only resource that we are seeing from big companies in the developed world, the asset that we have here is market, right? So Africa is 1.4 billion people. South America is about 440 billion people. Okay, so let's talk about South America, Brazil, and Rio Grande do Sul. And the global view, I think Latif already introduced it very much. I took here some data that shown that if you take a decade in which China electronics output grew 25% per year on average, okay, they grew from let's say a share in the industry that was really electronics industry very small, 2%, to about 40% in 20 years. So in 20 years, from 92 to 2012, China went from 2% participation in the electronics output to about 45. It became the factor of the world. Take China here, for instance, grew 0% in 15 years. Okay, and basically decreased it from its participation. So basically, China became the manufacturing hub in the world. The electronics production today is over $2 trillion, on the order of about 2.4 trillion today. But you could see that production basically move it to Asia Pacific. I don't know if my mouse shows. Does my mouse shows? Can you see my mouse pointing here to Asia
Yes.
Pacific?
Yeah, we can
Thanks a
see
lot.
that. Thank you.
Thanks a lot. Okay, yeah. So here, oh, I think I can see here the other. Okay, so so here basically the East became gradually since the 90s to today the manufacturing, and we are the rest of the world, right? Africa and South America are part of the rest of the world. Even North America here, there is, as you mentioned, the assembly platforms in Mexico, in North America. But when it comes to chips, North America is basically US. But when it comes to electronics manufacturing, then you have the assembly being done at Mexico, North America. But looking at the entire industry value chain, okay, the market for subsystems, border and module. Basically, what Africa is doing is trying to get a presence in the subsystem, border and module assembly, which is level three, third level of this, let's say, supply chain going upwards from materials, tools, and then to chips and other electronic components. So the second level is electronic components, in which semiconductors today is a $640 billion market, $640 billion, right? Those values are outdated, but a more recent data, $600 billion, and basically you have other components like resistor, capacitor, passive electronics is let's say 1/3 of that market, or in less, because more value is added, is being to the left. And overall, it's feeding an industry of system level, which is basically of the order of $2.3 billion. Okay. Brazil in the year 2008 produced $37.7 billion of the of worth of electronic goods. Today, 2020, last data that I have, 2021, we're at the same level, between 33 and 35, 37, depending on which exchange rate you are using. So Brazil did not grow from 2008 to 2022. Okay, it did grow in the 2005 to 2008. Okay, um, I'm not going to discuss the reasons for that, but it has to do with the exchange rate because it's in dollar. And so basically, the electronic industry in Brazil is about $35 billion. It's still today, even the same level it was in 2008. That's why I say it's a sluggish, let's say, situation. While electronic production all over the world, right? You see that the IoT wave, and that basically merge data processing and wireless, is where the dynamics is going to be. But automotive and industrial and medical applications have also shown some reasonable growth and will continue to have good growth, especially the automotive, industrial, and the IoT. Okay. Um, and taking a larger perspective in history, coming from the 70s. So here in red, you have the growth of the semiconductor market, right? So, and here is have the wave, the electronics industry. So we are here at the level of $2.2 trillion right here today, 2022, okay, which is more or less along the historical growth rate, okay, to between $2 to $3 trillion. Roughly today, we have a market that is a little bit stronger than that. We have in 2022, we have 640 billion. Okay, this forecast had predicted to be a little bit larger than that, but it was done. This forecast was done in 2010. Okay, 2005. So yeah, the semiconductor industry is growing, and of course because it's driven by this IoT, where you have ubiquity, and now you have IoT wave. But IoT is a variety of hundreds of thousands of different products. So to add those things up is really not easy. And of course, the semiconductor industry had cycles of fast growth, some decrease, peak, and then it had a peak also into 2017, 2018 in memory market. Now so it's an industry that follows the waves. And this has already, if you look at the global value chain, Latif already made a very good point that I agree with, is that you have to be in the driver's seat and capture a good part of the value added. You have to be here in the phase 1 and 2, where you are doing either product design or designing critical parts and subassembly components. While when you go to parts fabrication, you either do it in wafer fab if you're going to produce a chip, or you do it in EMS, contract manufacturer company, for doing the fabrication, the assembly, and final assembly test. That is step 3 and 4. It was outsourced. It's offshored to China and to the Far East, as in general, in the 70s and in the 80s and the 90s and the early 2000s. And now there's a tendency to try to reshore and have more manufacturing base. But the value added is at the beginning of the chain, and also here at the end, where you're doing basically distribution, marketing, and stuff like that. So the big let's say value added is with those which innovate, and you have to be more innovative. So that calls for action for the educational system to take part of that. So I talked about offshoring. So basically, 3 and 4, the stage 3 and 4. When I say parts fabrication here, I mean that could be chips, right? So they have to go to a wafer pure play foundry. If you're doing fabrication and assembly, you are putting SMT boards. Then you are doing a fabrication also, but you are doing assembly and test at the same time. And then this industry here is highly focused now also in some value highly important and critical, which is the pure play foundry business. So the foundry business, okay, the one that's pure play, that means the company just manufactures for third party. And you see here the forecast was in 2022 to be a market of about $80 billion. This forecast done in 2020 is wrong. Actually, this grew faster and now is around $90 billion, and it's going to be in 2-3 years 110, 120 billion dollars of foundry business. But here, this I see insights. They select what's pure play in red, like TSMC, Global Foundries, and some IDM foundry sales. There are some IDMs like Samsung, which also do outsource manufacturing of wafers, and they have already a sizable production, right? So, in Intel this year announced that they will enter this business of a foundry for other companies. Okay, so yeah, the IDM foundry business is going to grow probably more rapidly than shown here, because big players like Intel, which is the largest wafer manufacturer, is going to enter this business. Okay, but you see this there is a high geographic concentration because the pure play wafer capacity, wafer fabbing for pure play, as of 2 years ago, was highly concentrated. About 75%. It's concentrated in Taiwan, which is a leader in that. South Korea, in which Samsung provides, Samsung Foundry provides services also, and Japan and China. And China is growing, and what happens is that the reshoring tendency that has been seen since the last year, uh, as Latif already mentioned, it's on the news media, is that Europe and North America decided to reshore wafer capacity. The wafer capacity here is shown in million like wafer starts per month. So that's installed capacity. That's here. So normalize it to 8-inch wafers. So basically, the rest of the world here does include basically here. Africa has no wafer fab, and Brazil and South America doesn't have any wafer fab. Actually, Latin America doesn't have. Even Mexico doesn't have a wafer fab. So the rest of the world here is Malaysia and Israel and Thailand and some few other countries. Singapore also. Singapore in Malaysia here. Okay, they account for that. Singapore in Malaysia because UMC has factories, wafer fabs in Malaysia. Excuse me, in Singapore. Okay, so basically, what's the position of Brazil? Okay, Brazil has about when I look in detail, it's about 2 to 2.4% of the world production of electronics is done in Brazil. Okay, uh, here in 2007, the rest of the world was producing just 50 billion, right? And China grew its share, and Europe decreased its share, as well as North America. So the manufacturing moving to Far East, provide accelerated growth in the production in East Asia. But the question here is where is the value added? The value added is added mostly, the highest return come from the design of the product. Okay, and if you look at the electronics business, basically you see like integrated circuits today is in less than 10 years it doubled. In 8 years it doubled from 280 to 509 last year, more than double. And the semiconductor equipment business just not double also because it's driven by that from $50 billion of capital expenditure in equipment to about 100 billions just to keep those fabs, not only the pure play, but all of them working. One thing that hasn't changed much over the years is that the value of each IC, on average, just IC, not discrete semiconductor. Taking discrete semiconductors out of the picture, you have the average price, average selling price is about $1.50 most recent because of pressures from the excessive demand, and the supply chain of semiconductors was strained because companies to be viable have to use over 90% capacity. Last year, 2021, all factories operated, all wafer fabs operated 98, 99% capacity. You cannot go 100% because you have downtime of equipment and so on and so forth. So this industry is highly intensive in capital expenditures, right? Highly demanding in R&D expenditures, and this explains why countries like in Africa and in Latin America don't grow the semiconductor business in the front end. And they have some opportunities in the back end, which have been captured by few countries, and like in Brazil, back end of the chips encapsulated. So in Brazil today, they have about $1 billion industry a year for packaging chips. Okay, and there are some 5 players in Brazil, companies doing chip assembly, so encapsulation of chips, and their revenues selling those chips mostly are memory. More about 90% of this revenue, 85% is packaging flash memories and DRAM memories for the which are delivered to the electronic manufacturer companies doing business in Brazil, like Foxconn. They are assembling Apple devices and so on and so forth. So the global value chain, you can have to look in two ways. Where is the production, and where is the engineering? Where is the engineering value chain? Where is the production? Because that has already been mentioned. The engineering chain, especially the semiconductor equipment, okay, which is very, very complex systems, they incorporate the advancements of semiconductor production. They are highly concentrated not in East Asia, and that's why that allows the United States and Europe to rapidly reshore their factories, because different than China, which is subject to restrictions from the U.S. not allowing semiconductor equipment to be delivered there. They're not the state of the art. So this geopolitical war over Taiwan's business, Korea business, and China, and the war that the United States wages against the growth of semiconductors in China is done through the semiconductor equipment and the supply of equipment, the assemblers, basically the clean room equipment that goes in clean room and the assembly machines. So the multinational companies continue to grow in importance because they control the critical technologies. And my point is there are extreme levels of specialization in the global value chain that have to be captured by countries like us. And for small and medium companies, small and medium enterprises, is very difficult to enter if they are not integrated through very specialized competences into the value chain of larger firms. So So electronics, if you look at the world trade, electronics is the largest and fastest growing component of the global trade in manufactured goods. So there's a trade of manufactured goods. So it's much better for the big multinational companies, it's better to assemble TVs and heavy stuff, TVs and appliances in Africa, in Latin America, and serve the local market this way. So that makes sense. And then what's traded and exported are the components, okay, which really embed the the critical functionalities and so the electronics the electronics components industry is one of the few industries for which the growth in the trade of intermediate goods has been growing a much faster pace than the trade in final goods. Okay, so there are consequences of what I'm saying in terms of outsourcing and offshoring. So there is outsourcing of engineering because of lack of talent. That gives an opportunity for us in the less developed regions of the world to be doing engineering services and then be part of the phase 1 and 2 of the production. Okay. Now the trends of outsourcing from the industrialized country to the poorer countries, that is for chip manufacturing is being revised by this national strategies of the central countries like Europe, European Union, and United States. And Japan is a different case in their strategy. Okay, Japan lost from the 80s to now. Japan lost position in the semiconductor industry. So my message today to you is that you have to understand the global value chain of both production and engineering, and understand that the fragmented and modular character of this global electronics creates opportunities and risks for newcomers like Brazil, Kenya, and even in Egypt. Latif mentioned the case of Egypt. Egypt is becoming for Africa, with respect to the East Asian companies assembling there, what Manaus in Brazil, the city of Manaus in the north of Brazil, has become for the same companies. Manufacturing hub for assembling the final goods. Okay. So if we understand that, we have to understand what are the opportunities for attracting narrow value chain segments, and understanding that there are risks of becoming too specialized in low volume added segments. For instance, Saytech company that has been mentioned here before by some of my colleagues, probably, they specialize in high volume, very low value added segments like tags. So they never grew they could never grow substantially in their revenues because of that. They did not choose a higher value added segment to produce chips on. And as a fabulous company, Saytech basically didn't have success after 10 years, and it was slowly coming up, and then the government decided not to. I had some slides here talking about the global tendencies that we have to, instead of going to boxes towards solutions and systems, from integrated models towards more creating innovation ecosystems to address that, but I'm not going to discuss that. But I'm just going to put some data here in Brazil, that Brazil was in 2011 to about 70% was basically primary products or resource based. So Brazil is a primary goods and very low complex manufacturing resource based goods like pulp and paper, and those are not considered high tech. So basically, 70% of our exports is primary and resource based, and while the high tech is only 4%, and it's not growing more. And to show how the manufacturing sector in Brazil has been stagnant, even in the years 2005, 2015, in which we had some policy for high-tech industry here, government policies, we had a substandard growth in the manufacturing sector, considering all industry. Now I'm talking not about electronics, but all manufacturados, all manufactured goods from 2007 to 2013. Just to show Brazil grew in this period around the average of the world growth, economic growth. You see that the imports basically doubled, more than doubled, and while the exports just grew about 10% in dollar. Okay, so the trade deficit in manufactured goods, okay, not just electronics, but manufactured goods, was $10 billion in 2007, just grew by 11 times. What happens, even in the years in which Brazil had the federal government had a policy of industrial policy to trying to get the industry to move upwards in the value chain and grow, our demand in those years of growth was supplied by imports of manufactured goods. Okay, so all sectors lost for the internal production lost for the import growth. So basically, this is a data for Brazil, a scenario that basically for the microelectronics, I have made a study many years ago that where can you start in design house? You can start with verticalized design house inside the company. We have here two of those DH1s design house, like we used to have NXP, prior it was Freescale, and now it's HCL. We have some independent design house, about 10 of them are working in Brazil. Foundries, we have none. And level one was kind of SATEC with investment of about $100 million, $160 million investment in the fab. And Brazil tried to build a foundry level two, but it never succeeded to put it to work. So under the standards of a global industry,
we are already out of time.
Okay, so how to insert, just for the discussion, how to insert the original companies in the rapid innovation chain of IT systems? That's the question that Latif posed, I'm posing also. I'm just pinpointing, pointing to two initiatives that started in 2005, and the Brazilian government, the current Brazilian government, ended those initiatives in 2019. SATEC company, a small fab, about 1,500 square meter of clean room here in Porto Alegre, and the IC Brazil program. All of those two initiatives were discontinued after 14 years. Okay, and also there was for 10 years the initiative in Minas Gerais for the Brazilian semiconductor company, then became Unitec company, and sadly it never started up. They built the clean room in these 2 years here, but in 2016 there was a coup in Brazil. They ousted the President Dilma, and the incoming president just had a different policy that said, no, let's forget about this investment. They never produced a wafer in this Unitec company. It's sitting there, about a 4,000 square meter of clean room that was never being put to use because the government decided not to go ahead. So I have some other data, and the challenges are in design, product design, and design and fabrication of critical components are highly valued. And of course, like Latif, a very competent person, can do knowledge consulting and do some knowledge-based, let's say, associated design. There is a group, for instance, there in the northern part of Colombia, who is doing consulting and design of chips for companies in Silicon Valley, right? I know those guys, I know this company, I know the professor who started that. So it's there are some cases, small cases of not doing the entire design, but doing and the biggest opportunity in IoT is selling the final services, which are associated to the tags, to the hardware, and sell the communication services. So I'll end here just to start the discussion and to understand how the local electronics industry in South America and Brazil can move from component to systems and have expertise to capture higher value added in this thing. Because assembling does very low margin. I think Latif already pointed, there are 5 to 6% value added when you do assembly of the board. So they work with very low margin. They depend on very complex global supply chains. It's very easy to move this thing worldwide if you're operating as a contract electronics manufacturer. Okay, and of course, I'm not saying that I'm still saying that having highly automated electronics assembly EMS is important for a country. Is important, okay, even though it's is the lower value added is important to start. And Brazil has this industry, and it contributes to efficiency, and it still can produce things for the local market. So with that, I stop sharing, and let's move to the questions with our people here in the
Thank
audience.
you.
Thanks, Ricardo. Thanks, Latif.
So,
I had more data to share about Rio Grande State data, how many companies, what they do. Uh, Basically, the electronics industry in Brazil is about $35 billion. The same value that it was about 20 years ago, Latif. It's incredible, right? So just serving the local market, using the multinational EMS and the multinational strategy for occupying our market, a market does not provide a road to growth. That's a message to the African authorities and a message to the local authorities in Brazil. We did not grow. So they have the example of Brazil, in which the electronics industry, the production side, was stagnant for 15 years, even though the government wanted to do better, wanted to move up some initiatives. But again, we need to enter this value chain in this engineering chain with a better strategy. And if we just play the game of the big multinationals, okay, Samsung, LG, and they will be occupying the African market as they occupy the market here in Brazil, taking the market out of Philips and Sony, okay, by doing efficient manufacturing, because the critical components are done in Korea and Japan and so on and so forth, so that they just send it to Egypt to sell TVs to the African market, or as they do in Manaus here in Brazil, where Manaus has about $40 billion of production of all goods, like motorcycles and all consumer goods or consumer electronics, like audio and video is produced in Manaus, with no technology being aggregated in Manaus. Okay. Yeah. So we are giving incentives to the multinationals just to assemble, and we have to give incentives to the small and medium companies here who are able to put us in the value chain in a more, let's say, let's say, value added, but with more possibilities to grow. And so, for instance, for Latif, your company is not just EMS. You have to move up to design. So if you don't move to design, Latif, your EMS will not grow. Okay. So if you don't go to the customer and you do the design of the product all the way down to design of the component, then you don't bring value added to the local market. You don't grow as fast if you don't do it. So you have to understand that. And
Absolutely,
our problems are similar, because we are seen from the outside multinational. We are seen as big markets. South America, 440 billion souls. Africa, 1.4 billion souls. We are seen as markets to be occupied, not as some society which is diverse and wants to grow from innards with our own feet.
Yeah.
Okay.
okay, thank you, Bumpy. So we are 11 minutes late in our schedule, but anyway, if someone has a short question, should do now. If no, I give the floor to Latif to give some final comments.
Yeah, I think as we wait for the question, I completely agree with what you're saying, Sergio, and I think the dissemination of technology, especially when we're looking at chip design, just a decade ago, chip design was relegated to your big fab companies now, but now you have much smaller companies that can do chip design. So if we can harness the education system to start looking at designing at the component level and adding value there, who's to say that we can't, design chips that are best suited for this market and create the value at that point. So, and I think this is a really good conversation to say, these are the needs of the market. This is where we think it will go. How do we harness education to ensure that it runs in parallel and provides the knowledge for us to get to where we're going? Because we definitely don't want to be in a situation where we're not adding value, you know, and all we're being used for is cheap labor, which means you'll be replaced, you know, a
Yeah,
couple of years down the road.
for instance, in my university, I had some data here also, Ricardo, about the output of master and PhD students we had in Rio Grande do Sul since 1981, but I don't know if Thiago shared that data, right? So we could host some design companies and start SciTech here about 20 years ago because we had this investment done in our university in the R&D part, educating highly skilled engineers at master and PhD level in microelectronics design, and that allowed our state to really harbor some investments in IC design. Okay, but as I told, they are small companies still, operations which, let's say, gross less than $10 million a year, right? And I mentioned the case of Bucamaranga, where our good friend, active in CASS and Solid State Secret Society, um, Professor Roa, okay, in Roa, he designs things for products to incorporate designs in products being done in other companies, which will in turn be parts of big contracts with bigger companies. They will be fabricated in somewhere in some foundry. So we understand this value. So our universities, okay, have a role to play, but we cannot do it alone, right? We need that the investors understand that there is, many opportunities in the IoT chain, as you mentioned, which are critical to improving our societies at all levels: efficiency of manufacturing, efficiency of public service, efficiency of education, and we can provide that to our societies if we understand that design engineering is important. Because when I go to most presentations, right, you see data like the ones I presented. They have the production output in $1 billion and whatever. Okay, so production, consumption. Okay, but where is the you understand the the value chain of the production? I want to understand the value chain of engineering, right? And we want to see more companies coming here to design things and not just assemble them. Okay, so unfortunately, Brazil since 1965 enacted let's say a free trade zone in Manaus. Okay, under the excuse that they need to develop the north of Brazil at the heart of the Amazon region, right? And this policy has been in place for 60 years already, 66 decades. Okay, and what they do, they harbor multinationals which want to assemble final goods there. So what happens is they import free of taxes, and they are able to serve the Latin American market, including Brazil, with products in some areas. But they have not the local capability to design IoT device, for instance, because markets in IoT sometimes they have to be identified. They're very niche specific, and they are they can grow very fast if you are successful, but they can be you cannot do a wrong bet. So you don't find design houses in Manaus, okay? Which is you find design houses here in Porto Alegre, in Campinas, in São Paulo, where you have highly qualified engineering school like ours, right?
Okay, Bump. So I'm sorry to interrupt, but we are already quite late in our schedule. So we still have now a presentation about the chapters, and then also 1:30 we should start the CASS talk schedule for today with Sandro Ferreira. And so I would like to thank you all. We could talk about this subject for several hours yet. Maybe we should do another meeting to keep discussing about the industry in both countries. No? So thank you
Yes.
very much, Latif, and thank you very much, Sergio, to
Okay, regards to
participate.
Latif and regards to
Sorry
Ricardo.
to interrupt you, but we needed to go ahead with our schedule that we are already almost 20 minutes later. No?
No
Okay,
problem.
let's
So
Sergio, I'll get in touch with you later and we can continue
okay,
the
thanks.
conversation.
Ricardo has my
okay,
email. We should almost share off.
yeah,
Our two officers are side by side. Okay, bye.
yeah.
See you.
Fantastic. Thank you. Take
Congratulations
care.
to all of you. Congratulations to the CASS chapter of Rio Grande do Sul and Kenya chapter. Successful activities to all of you. Bye bye.
Bye-bye. Thank you.
Thank you all. So now we go to the next session where Professor José Rodrigues Zambuja, that is the chair of the CASS chapter Rio Grande do Sul, that, as you know, got again the World Chapter of the Year 2022. So it's the fourth time that the chapter got this award. And also the chapter got for 5 times the chapter of the year in Region 9. So I think Azambuja now will share some of the activities that were the reason to achieve these awards. No? So, José, thank you. The floor is with you.
So thank you, Ricardo. Can you hear me? Is it okay?
Yes, I can.
Okay. So thank you for the introduction. It's my pleasure to be here presenting a little bit of what we do in the CASS Rio Grande do Sul chapter. I have a brief. It's not actually a brief presentation, but I am going to make it brief. So let me start by introducing who works directly on the CASS Rio Grande do Sul chapter. So we have what we call an EXCOM, which is the executive committee, and then we have bigger committees, and then finally we have our members and the whole community, right? Scientific, academic, and industrial society. So the executive committee is composed by myself, and then Rafael, Paulo, Cláudio, Fábio, Caleb, and Ricardo. So as you can see, we have lots of people coordinating the activities of our chapter. It wasn't always like that, but it has been like this for the past, I believe, 5 or 6 years at least. So on my presentation, let me just show you where Brazil is. And here in Brazil, we have Rio Grande do Sul. It's right in the bottom here, the bottom part. You can see Rio and São Paulo here in the southeast side of Brazil. The north is here with all the beaches and so on. And then the Amazon is here. And this is the inner state of the South America. So we are here in the bottom of Brazil. We are not far away from the main centers of Brazil, which are São Paulo and Rio. But we are closer to Uruguay and Paraguay and Argentina than we are to São Paulo, for example. And specifically, our state has lots and lots to offer. We have lots of countryside. We also have some seaside. It's not, we don't have the best seaside, but it's okay. We do have some forests, some rivers, and so on. So, and Porto Alegre is right here. So let's talk about the chapter. We've won a couple awards already. We won the first time the Chapter of the Year award in 2011, and then again in 2012, and again in 2018, and again this year. So the 2022 Chapter of the Year award is related to our 2021 activities, so our last year activities. So my idea here in this brief presentation is to show you more or less what we do in the chapter, also how we do things, and then I have a last slide about some do's and some don'ts. So let me show you some of our activity, and then after I present you these activities, we can discuss some do's and don'ts. So like very briefly, okay, this is also kind of what our report to CASS looks like. So we do lots and lots of events. We have some bigger than others, but we have some events that we directly organize. We have some events that we support. We are part of all these events, but some more and some less. So we have one big event, which is the where is it? The CASS workshop. This is the one, CASS workshop, plus some young professionals workshop. So this is probably the only event that we propose, organize. I mean, this is an event that we do absolutely everything. Just give me 1 second. I have to connect my phone here. 1 second. My battery is running low. Sorry for that. So let's discuss briefly these events. So the first one is called a South Microelectronics School. This is more like a basic courses on microelectronics with some advanced courses, but it focuses mostly on the basic courses. As you can see, it's a 5-day event with lots of courses. Last year it has been all in Portuguese. These years had some English talks as well. And then we had this IoT student contest where we find some companies that would donate some kits, some IoT kits, and then students would make teams to compete for the best product. And then we have the chip-in event, which is happening again this year in a couple weeks. Last year it was virtual from São Paulo. This is one of the events that we help organize, but we are not directly organizing it. So it's again a 5-day event. We also participate in the Synopsys Annual International Microelectronics Olympiad. So this happens every year all around the world. We had only 3 participants this year, but we usually have a little bit more than that. And then this is a microelectronics small event in Paraná. So it's not in our state, but we support their event. It's mostly focused on analog design and analog systems. Then there is this CASS-W. This is the CASS workshop. It's always in Porto Alegre, so because this is the event that we always organize. So it was virtual from Porto Alegre, and it took, I think, 3 or 4 days last year. Check. Yeah, so 3 days of events with some talks in English. All of these talks were in English. We usually invite past students and so on who are in academia or on the industry. The DPVSA stands for Digital Processing of Visual Signals and Applications. This started as a seasonal school. We still call it seasonal school. It was last year. It was the 5th edition. We are organizing the 6th edition this year. It's going to be in November. And is of course focused on the digital processing of signals and so on. And then by the end of the year, we had Ceresa. Ceresa is mostly focused on the radiation effects. So we organized Ceresa twice. This is again an event that we are not directly related to it, but we work a lot on this event. So we support them very hard in this event. For example, the general chairs, if I'm not mistaken, were Ricardo and Fernanda. last year, same as the previous year in 2020. So this was 4 to 5 days, and then this year we had we participated the first time in the Mocitec. Mocitec stands for a science fair for the undergrad, actually for the schools, right? So this is a way that we can connect to schools and students that have not yet reached the university. So it was a 3-day, I believe. And then in the end of the year, this is the second event that we always organize internally, which stands for the CASS meeting. So the CASS meeting is when we report our activities to our members. So we had the WeCAS, which stands for Women in CASS, and then the two meetings. The first meeting stands for CASS meeting. We had some student design competition, panels for international insertion, highlights from 2021, and this is when we plan the next year. And then there is the SEDA meeting, which is Council on EDA. We are very friends with the organizers from SEDA, so we usually organize both events together. Usually SEDA is in the morning and CAS meeting is in the afternoon. Then we have our social media. So our main social media is our YouTube. So as you can see here, last year we had 1.86 thousand subscribers. We currently have about 2.15, I guess. So 300 subscribers more. And this is where we organize our industrial talks and our CAS meeting. So we have a CAS meeting today in an hour, I guess, in half an hour, with Sandro. So these are the industrial talks. So we didn't have many industrial talks last year, only 3. And for the CAS talks, we had many. I don't even know. I'm just going to pass it really fast here. You can find all of them in our YouTube channel. So as you can see, plenty of them. I have the numbers in a couple of slides here. So as you can see, lots and lots of them. So we also have some special events. So we had this event, the meaning of assessment in higher education. This is not actually a CAS talk, so we call them special events. We also had the second CAS women in, the second WeCAS, which stands for Women in CAS workshop. And also we started our Instagram last year. So we currently, we had about 900 followers. We are not really good at Instagram and Facebook and this kind of social media. We are still working on making it better. And so you can see here our YouTube channel. You can find, this is actually, probably if you're watching us now, you are on our CASS Rio Grande do Sul YouTube channel. So we usually transmit live events to YouTube, and we also keep the talks inside YouTube so people can see them later. So finally, what we did last year, we had 87 talks plus 36 CAS talks, and then 3 industrial talks and 2 special events, in a total of 58 YouTube uploads. So that is a lot. That is 128 talks in total, and we had about 20,000 views on YouTube, which is really good. But this is something that we've been working on for at least 3 years now. So that is one talk every 3 days, which is a lot, and 56 views on YouTube every day. So this is, I mean, this is really good. And again, this 2021 was one of the best years. I wouldn't say it was the best year, but one of the best years in our history. So for 2022, we are organizing CAS talks plus industrial talks. So this is what I mean by we have a CAS talk in half an hour. E-Micro SIM, which is the South Microelectronics School and the South Microelectronics Symposium, was in May. The Chipping the Minuano is going to be in 2 weeks, I believe. The CAS workshop, we have we have planned it already. It's going to be, I believe, in November instead of October. I believe it's in the beginning of November. The seasonal school, the DPVSA, is going to be also in November. And then Mono 3D, PDA, and ADAS, I'm not sure yet if they are going to happen this year. I don't think so. And we are also planning another CASS Tech Day. This is one of my favorite events where we invite people from the industry to talk about opportunities and what kind of engineers and what kind of people they want from us. Mocitech is happening again, and CASS meeting always happens in December. We are also planning the student design competition, so we started fomenting new teams in January, I believe. We are going to have some presentations already in 2 weeks during the Chip in the Minuano, and we are going to have the student design competition, the official student design competition in December. So these are only some of our activities. I am probably missing something here. We organize so much things that I sometimes forget about it. So this was our activities report from 2021. And then I have just one last slide about do's and don'ts. So this is more like a topic of discussion. And I'm going to give you some of my views on starting a new chapter, what you should do and what you should not do. So first of all, the executive committee should be very well defined. It should meet frequently. So we meet once every month. We have about a 1 to 2 hour meeting every month, discussing what has happened and what we are going to do in the future. So this is, I would say, this is mandatory. Another thing is interchange between other chapters and between other organizations inside and outside of IEEE. So councils and other chapters. So Bumpy here, for example, he's, I believe, the chair of the EDS chapter. So we talk like frequently about opinions. We share resources. So our StreamYard, they usually use it as well. So we share people between the chapters. We would like to have a better connection with ACM and people outside of IEEE. So this stands on the do's. And about organizing events, I believe that there should be some events completely organized by the chapter, which happen like 1 or twice a year. For example, in the beginning of the year and later, I wouldn't say in the end of the year, but let's say May and October, or May and September, something like this. 2 events to gather the community and then discuss things and do panels and do everything on those occasions. CASS usually have some open calls for outreach and seasonal schools on given subjects. So you can usually finance some schools or some events, some panels, and some things like that every 6 months. So I would say this is a good idea. On the don'ts, I would say not to organize too many events and not to centralize everything in just one person, because it's too much. As you can see here, let me go back one slide. We organized 128 talks in 2021. Imagine centralizing this in a single person. It doesn't work. It doesn't scale. So the planning of the chapter is really important. And of course, the implementing the talks and so on is also very important. It is very time consuming. Usually members and the audience, they don't realize how much work it is to organize something. So I would say try to not centralize everything, discuss and plan very well. And these are my main tips for having a successful and easy to manage chapter. So I think that's it, Ricardo. These are my main points.
Okay, thank you. So if someone has any question, please do it now. I was waiting also for Mr. Mumble, that is the Kenya chapter, to say something, but he's not now in the StreamYard channel. And also Fidel has not arrived yet. So, but if you have any question, please, you can do that now. Waiting for questions, I'm also use this opportunity for some publicity. So, as José told, soon, in 2 weeks, we have the chip in Minuano that will be completely virtual. So, besides the time difference, it's available for anyone in the world. And you can see here that we have 4 very nice keynote speakers. And if you go to the web page of the conference, you can see the full program. So the SBCCI was launched in that is the, let's say, the conference dedicated to integrated circuits and system design. The first edition was in 83 here in Porto Alegre. So next year we are going to celebrate 40 years of the SBCCI. So, and the proceedings of SBCCI are published in IEEE Explore. And together in the event also we have SB Micro, that is the conference dedicated to devices and technology. Insist, that is instrumentation. WCASS, that is a workshop on circuits and system, and the student forum. So as it will be a fully virtual edition, the registration cost is very low. Then this is the flagship conference of CASS Society, so the international conference of CASS Society each year in South America or Latin America. So next year, LASCAS will be in Ecuador. So the deadline is September 4th. Maybe we are going to have 1 or 2 weeks of extension. It's not yet confirmed, but we have still some weeks to prepare a paper. And in parallel, co-located, we have Iberchip that also allows students and research to submit the paper not only in English, but also in Spanish and Portuguese, and primarily that is the CASS conference dedicated to PhD students. No? By the way, LASCAS 2024 will be in Punta del Este, in Uruguay, so it's not so far from Porto Alegre, where we are, and 2025 should be near Porto Alegre in our wine region. No? So it would be great to have a bigger participation from Africa, as we already have submissions from all around the world. And there is also a fast path to have best papers, extended versions in IEEE transactions on sequencing system 2 and transactions on sequencing system 1. Then there is also a nice opportunity to come to Brazil next year. The IEEE Computer Society Annual Symposium VLSI, also with the support of CASS Society and the Council EDA, will be in Iguaçu Falls. So this conference moves around the world. And so June 20 to 23, it's a great opportunity to come to a good conference, and with that will be available the proceedings in IEEE Explore. And in a very nice location, as you can see. So I was so waiting for Fidel for the final remarks, but he's not yet here. So I would like to thank all the speakers that participate in this workshop today. So it was, I think, first time that we have a joint workshop between chapters from different continents in CASS. So, and we hope that soon we can have also a in-person workshop between Latin America and Africa. So thank you all. And as you know, our program today is not finished yet. So in 15 minutes, we have the CASS talk that will be given by Sandro Ferreira. And so this next presentation, so in 15 minutes, Sandro Ferreira is a professor at Unicinos and is going to talk about the design of high IF discrete time receivers for IoT, demystifying alliance and trade-off. And as it was already told you, if you missed the CASS talks that were done in 2020, 21, in this year, the recorded versions are available in this YouTube channel. So the same one that we are now. But now for the CASS talk of Sandro, you should go out of this session and select in the YouTube channel the Sandro Ferreira icons to attend his talk. So see you in 15 minutes in the other link that is available in this YouTube channel of CASS Rio Grande do Sul. So thank you all, and see you in exactly 15 minutes. Bye-bye.